Hope all you are seeing my my screen. EMTP is an electromagnetic transient program software, which is a time domain software. It is technically and fully featured advanced software for the simulation and analysis of all types of system transients like electromagnetic and electromechanical transients. Here, these are the contents of today's presentation. Before going in detail into the EMTP software, I would like to provide a brief introduction about our company. The headquarters of our company is PWSIM, which is situated in France. We are having a 17 years of experience in the field of power systems, and we have branches at different areas in the worldwide, USA, France, Germany, and in India also. In India, the company name is registered as a PWSIM Engineering Solutions Private Limited, and in India we have an offices in Chennai and Bangalore. PWSIM is a consulting and software company to provide the services in the field of electrical and electromechanical power systems. We are providing the different comprehensive softwares for all the types of power system applications, and we have a complete range of services for support, like we can provide the technical support, and for studies we are providing the consulting services related to the insulation coordination, ferroresonance, harmonic analysis, TRV analysis, like that. In training, we are providing the FDP programs and workshops to the colleges and industries also. And we have a strong relationship with the developers to provide the best solution for the electrical problems. And we are having a connection with the worldwide network partners to develop the EMTP software according to the requirement of customers. This is the major activities provided by the PWSIM. We have 3 verticals here: engineering consulting, software distribution, and IT consulting. In engineering consulting, we can provide the finite element analysis and power systems. So in finite element analysis, here we can able to provide the electrical machine design, like transformer designing, machine designing, transformer designing and machine designing and motor design we can do in the FEA analysis. In power systems, we can able to provide the analysis for the steady state analysis and transient domain analysis. And we are providing the consulting services like ferroresonance analysis, harmonic analysis, TRV analysis, and switching transients, lightning transients. All the consulting services we can do by here. In software distribution, we have a different softwares are available with us to provide and to cover the different applications, wide variety of applications like renewable energies, electrical energy, automotive, aerospace and defense, transportation. All these examples can cover by using the different softwares. Here, this is the software portfolio available with PWSIM Engineering Solutions with different applications. In electromagnetics, we have a software of JMAG. JMAG is a comprehensive finite element analysis software for the electrical machine designing like transformers, motors, generators, etc. In power electronics and drives, we have a PowerForce, Smart Control and PSIM software. PowerForce software, it is mainly used to design the converter designs with high efficiency and high accuracy mode. Smart Control, it is a control design software, especially for control designing of the power converters. And PSIM is also a software which is for the most important for the power electronics and drive applications. Sabre software, Sabre is a multi-domain physical system software which is used to provide the solutions for both power electronics and power systems. This Sabre software is mainly used in the aerospace and defense research organization. In those conditions, they are using the Sabre software. Cradle is a fluid dynamics software, especially used by the mechanical persons. And EMTP, it is a fully featured and technically advanced software for providing the solutions for all type of transients in power systems. These are the engineering services provided by us in India related to some insulation coordination analysis, TRV analysis, harmonic analysis, transformer energization, ferroresonance analysis. We have different applications we can do as a consulting services here. The main challenging missions of our company is one is business development, sales management, and we can provide the pre-sales and after-sales support, training and services. We can provide it to the colleges, FTP programs and workshops, and similarly we can provide the consulting services to the industries, and we can provide the technical support also based upon the feedback taking from the clients and customers. We have to develop our EMTP software accordingly based upon the requirement of them. Before going into the software, then why we are going for the electromagnetic transient program software? We all know in power systems, if there is a sudden changes in the system configuration, like opening the switch or breaker or closing the switch or a breaker, there is a sudden rise of voltages or currents will happen in the system. So it is very important to study those sudden rise of voltages or currents in terms of transients. It is very important to study those when we require the EMTP software. Like we are getting the power system transients due to the line energization, cable energization, capacitor bank switching analysis, and transformer energization. In all the cases, we will get the lightning transients. We are getting more transients, so we can solve the solutions by using EMTP software. In EMTP, we can solve the equations like here. I am taking the example of an inductance. We can take the equation as V of t is equal to L into di by dt. So to solve this equation, we have two types of solutions are available based upon the mathematical equation we have considered. First one is phasor domain. In phasor domain, we can take the Laplace transform of the differential equation, and we can take the Laplace transform of the equation, and we can provide the solutions for a given valid frequencies. This frequency is maybe the default frequency. It is a 50 Hz or 60 Hz. For one single frequency, we will get the output response in phasor domain solutions. If we are considering the time domain simulation, here in time domain simulation, to solve the equations, we will go for the trapezoidal or backward Euler integration methods with respect to the historical components available in the past events. So in EMTP, we are using the trapezoidal and backward Euler integration methods to solve the equations. Here you can able to see the complete difference between the EMTP difference between the time domain versus phasor domain. Here you can able to see the response of a red color waveform indicates the phasor domain waveform. Here we are getting the magnitude and angle of the waveform in phasor domain. And in time domain software, we are getting the actual waveform with respect to the time accordingly. So like this, we can differentiate the time domain versus phasor domain softwares and its waveforms. This is the classification of power system phenomenon. Here you can able to see the application of EMTP software from microseconds to seconds. If we are going for the microseconds, then we have a lightning transients after the switching transients, subsynchronous resonance. All these transients we can able to see by using EMTP software. These are the field of EMTP applications. In EMTP, we can do the power quality, geomagnetic storm applications, and the subsynchronous control interactions, HVDC, FACS. And similarly, we can do the grid integration techniques, power oscillation, saturation problems, TRV analysis, insulation coordination. All these type of applications we can do by using EMTP software. These are the EMTP main applications. Here you can able to see the main application of the EMTP software like lightning and switching transients, insulation coordination, HVDC and FACS like that. In EMTP, we have 4 types of simulation analysis: load flow, steady state, time domain, and frequency scan analysis. In load flow analysis, in EMTP, we can able to find the load flow solution for both balanced and unbalanced networks also. In both load flow and steady state solutions, we will get the output responses with a single frequencies, that is default frequencies. In time domain solution, we can able to solve the nonlinear equations and nonlinear components by using the numerical integration techniques. Here in EMTP, we are using the augmented Newton-Raphson method to solve the nonlinear devices and equations. These load flow and steady state simulations are used to initialize the time domain simulation. Similarly, in frequency scan analysis, we can calculate the input impedance of the system for the selected range of frequency. Here we can able to see the range of application or range of frequencies solved by the EMTP software. In EMTP, we can able to solve the load flow calculation and short circuit calculation for the default frequencies. It is 50 or 60 Hz. For transient stability programs, we can able to simulate the transient analysis from 0 Hz to kilohertz and megahertz also. But if we are going for the kilohertz and megahertz, then it is very important to model the each and every component in detailed model like electrical machines, transformers, lines, and cables. We need to add in a detailed model for as a frequency dependent. And in EMTP, we can provide the solutions from small to large scale of networks. In EMTP, we have a nonlinear devices are also available. Here in power transformers, VTs, CTs, we can add the saturation characteristics of the transformers, and similarly, we have a surge arrestor in EMTP. We can solve all these nonlinear devices in detailed model when we are going for the high frequency range of applications. This is the complete EMTP package. This is the complete EMTP package. Here you can able to see the EMTP works as a graphical user interface GUI. In EMTP works, we are able to do the simulation modeling and design modeling we are able to see, and we can do for different configurations of our design model. And EMTP has a powerful and superfast computational engine is available to solve those design models. To see the output responses in EMTP, we have a scope view is available. So in scope view, we can perform all the post-processing analysis, and EMTP scope view contains the advanced function editor to perform the all post-processing analysis and mathematical operations such as the harmonics and THD calculation. Similarly, for FFT analysis, DFT analysis, all the things we can perform it by using scope view. These are the add-on modules available in EMTP software, Exciters and Governors library. It contains more than 50 standard models, including of IEEE standard 421.5. Including of exciters and governors, we have a power system stabilizers and over voltage and under voltage exciter limiters are also available in EMTP exciter and governor toolbox. Protection toolbox. In protection toolbox, in EMTP, we have a different relay configurations are available with along with the fuse and thermal elements. Different relays are the overcurrent protection, differential current protection, distance protection. We have a different release are available. Some are the manufacturer release and some are the generic release are available. By using EMTP software, we can able to simulate and analyze the protection system in both steady state and time domain simulations also. Simulink toolbox. Simulink toolbox is used to import the Simulink models into EMTP software very easily. LIOV toolbox. LIOV toolbox is used for the calculation of lightning-induced over voltages for the distributed networks. PAM-suite toolbox. It's a parametric suite is used for the sensitivity analysis, optimization analysis, contingency analysis. To perform those analysis, we require the PAM-suite toolbox. Renewable toolbox. In EMTP, we have a PV and wind park models are available for the study of integration of those models into the power systems very easily. These are EMTP analysis, and it has an automatic initialization. The main advantage is a sparse matrix. Because of using the sparse matrix here, the simulation time is directly proportional to the exponential of number of buses or number of components used in the total system design. So based upon that, we can, if we are increasing the number of nodes or buses in the complete system, so Uh, the space matrix is used to provide the solutions as soon as possible. And EMTP is scriptable. We can develop the programs to create the models and other things by using JavaScript. This is the complete flowchart of EMTP software. Here you can able to see in graphical user interface, we can design our own models and we can import the data into the graphical user interface parameters. After that, we can perform the load flow analysis or steady state analysis or time domain analysis. In both the load flow and steady state analysis, or we will get the output responses of voltages and current flowing through the breakers, power flow through the transmission references. Here you can able to see the different manufacturing companies and the power grid, NTPC, all are using the UMTP software. And similarly for colleges like IIT Delhi and NITs are also using the UMTP software. Before going to the applications of the EMTP software, just I'd like to, I hope all the people have downloaded the EMTP software and install in your computers. If anybody has getting any error in the EMTP software, so just you can check your Windows update in your system and you can click on the check updates. After that, if you have anything you can update to Windows update, then you can update the Windows and you can install the software. Because of the Windows update only, sometimes you are getting the error. Just you can do that. Parameters you can enter into the line data and you can generate the line parameters. From the line parameters, you can directly import those line parameters file into the constant parameter line transmission line. And in EMTP, we have a line databases available according to the different voltages from 66 kV to 735 kV with different configurations like single circuit and double circuit line configurations are available, so that you can directly click on this what configuration you require, then directly you can import these parameters into the line data. From the line parameter calculations, you can import those parameters into the transmission line modeling. Similar to the transmission line, in EMTP, we have a detailed cable data model is also available. So you can enter all the cable data parameters into the cable data. After that, from that, we can calculate the parameters. We can import those parameters into the wideband or frequency dependent cables. Like this, we can import those parameters. It is a two-step process.
गली हो या स्टेडियम, क्रिकेट खेलने का हक सबका है। इसी तरह बिजनेस ऑनलाइन ले जाने का हक भी सबका होना चाहिए।
This is the main EMTP typical application of the lightning transients for insulation coordination analysis. Normally, the lightning transients are two types: direct lightning and indirect lightning. For indirect lightning, we have an LIOV toolbox is available with us to calculate the induced over voltages due to the indirect lightning in the transmission lines and conductors. Similarly, in direct lightning, in EMTP, we have a gray current source model is available in parallel with resistance. So here you can able to connect this gray current source model, this gray current source model to wherever you want in the system. Here you can see the example of lightning transient analysis. In this example, we are able to strike the ground conductors with 200 kiloamperes lightning stroke. So for lightning transient analysis, we need to model each and every component in detail. That means we need to model the stray capacitances of breakers and CT, VT, buses, all the things we need to model in detailed manner. And after that, we can able to energize, we can able to find the lightning transients and we can able to find the different voltages at different points. Those voltages we can compare with the basic insulation level of the equipment. Here you can able to see the tower top voltage.
First select the preferred language from the drop down.
Sorry. Here you can able to see the tower top voltage. In this tower top voltage, we are getting the oscillations due to the propagation waves of these towers into the substation entering. Due to that, we are getting the oscillations. Similarly, you can able to see the energy absorbed by the arrestor. so that you can model the surge arrestor in perfect manner. Like this, you can able to design your lightning transient analysis and you can perform.
Now leave
By using the
everything else
lightning
as they are
transient
and go
models, we
down to
can
the system
calculate the
tray.
rate of failure of the
Here
substation
you want to
and what
check
is the
these two
importance of the
options.
tower
First is
putting
to minimize the
resistance
OBS
connected to
recorder to
these
system
towers.
tray when
So all
recording.
the things we
And
can
then the
develop
second
and
is
we
to
can
always
model by
minimize
using
to
the
system
lightning
tray
transient
instead of the
analysis in
taskbar.
EMGP
With these
software.
two settings, you are able to have a full clean capture that wouldn't even show any
Next one
sign
is
that the
switching
screen is being
transients.
captured. And that is it for the
Switching
general
transients
settings.
are mainly
Next
occur
is the
when there
stream
is a
settings. Here you
opening
basically
and
need to select
closing
your
of
stream
breaker
service from the
switches.
drop down
At
and
that
then
time of
connect your
condition, we
streaming
will get
account
the switching
appropriately.
transients in the network. Here, there are some typical
Where
network
you have
events
this is normally
caused
where the
the
captured video
switching
files are saved on
transients.
your
These are
computer,
the transmission
format to
line
MP4.
energization and
Tamper with any of these
de-energization,
settings,
fault appearance
just
and
go
its
down to where you
elimination,
have the recording
capacitor bank
format,
switching, reactor
use
switching,
the drop down and change the
transformer
format to MP4.
energization. In all the
Now by
conditions,
default, the
we
recording
will get
path,
the
which is
switching
where the captured
transients.
video
Here you
files
can
are
able
saved on
to
your
see the
computer, is
example
your
for the
Windows video
line
folder. This
energization.
is normally a good
In this
location,
example,
but if for
we are
some reason you
energizing
want to
the
change
long
that, you can
transmission
simply
line
click on the browse
L4
button
with
and
trap
then select your
charges.
preferred
That
location.
means here you can able to see the switching transients at 50
Next, you want to
milliseconds
go to your audio
uh,
settings. Again, here don't
of
play
this
around with all these
receiving
options.
end bus.
By default, OBS is set to
Similarly, if
record
we
any
are
audio
clearing
from
the
your
fault,
desktop
that
and
means
also
at the
audio
time
from your
of current
microphone, which is
interruption,
basically the
the
audio from
breaker
the voice
has
or the environment.
occurring
This would be
of
perfect if you are
TRV
recording
and triple
voiceover
RV.
or making
So with that
commentary over
able
live stream
to
or
calculate
capturing your
those TRV
gameplay. However,
analysis
if
and
you
triple
want to
RV
have
of the
only the audio
system
from your
by using
computer and no
EMTP
other
software.
sounds from the
In
environment,
EMTP, we
then
have
you
an
want to go down to
IEEE
this
and
mic
IEC
stroke
standard
auxiliary
TRV
audio
envelopes are
and
available.
change it from default to disabled.
So we can use the
And
IEEE
that
and
is it for the
IEC
audio
TRV
settings.
envelopes. It is
Next, go to
automatically
the video
calculate the
settings.
system
Here you
fault
have two
current and
resolutions to
accordingly
set up.
it can use it
First
to
is your
provide
base
the
resolution, which is the
TRV
resolution of the
envelope
screen you are capturing from.
in the
By
as the
default, mine is
output.
on
Here
1920
you
by
can able
1080,
to
which
see
I
the red
highly,
color
highly recommend
waveform
for screen
represents the
capture.
TRV
Lower
and envelope
resolutions
of
would
the
obviously
IEC
offer you lower
standard,
video
and
quality, so
green
pay
color wave
attention to that.
represents the
The second
output
resolution
voltage
is
of
the
the
output
breaker. If
resolution, which
this
is the
voltage,
resolution of the
output voltage
captured
of the
video.
breaker is
Here again,
less
I would
within the
recommend you keep
limits
it to
of the TRV,
1920 by
within the
1080.
envelope of the TRV, so that we
Then
can
under
able to
downscale
say that
filter, I normally put
this
mine to Langsos
breaker
with
has
32
some
samples.
safety margin is available for this breaker. Like this,
Then
we
for the
can
FPS,
calculate
I
the
normally
TRV
leave mine at
analysis
30
and
frames
triple
per
RV of the
second.
breaker
This
very
is enough to
easily by
give a
using
very good
EMTP
quality smooth
software.
video without putting a lot of pressure on your
If you
graphics
want to
processors.
enable the
Of course, you can
restrikes,
set yours to
pre-strikes
60
and
frames per second
reignitions,
if
then
your
also you
computer
can
is powerful
enable
enough
that
to
one.
handle
If you
that.
want to include the strike
And then under
capacitances,
the
that is
hotkey
all.
settings and the
That option
advanced
is also available here.
capture that wouldn't, and that then you have the output
Next, this is the
settings. Here
example
again,
for the
don't tamper with any
ferroresonance.
of these settings.
Ferroresonance
Just
or
go
a
down to where you
nonlinear
have the
resonance.
recording
It is a
format,
type of a
use
resonance
the drop down
which
and
is
change the
occurred in the
format to
electrical
MP4.
circuit when there is a
Now by
nonlinear
default, the
inductance like
general settings. Here you first select the
transformers
preferred
and
language from the
VTs,
drop down.
reactors that is in
Next, you can
series with the
choose a theme of your
capacitance.
choice.
It
Here
is
we mainly
connected to
have
the
the light
cables.
and the
Then there
dark
may be
themes
a
with two
chance
in
of
between
occurring the
modes.
ferroresonance occurred in the transmission in the system. This ferroresonance, because of this ferroresonance, there is an increase in the over
Now
voltages
leave
and
everything
over
else as
currents,
they
which
are and
may
go down to the
damage the
system tray.
system insulation of the
Here you want to
system
check these two
insulation.
options.
So that
First is
it
to
is very
minimize the
important
OBS
to
recorder to
study the
system tray when
ferroresonance
recording.
analysis.
And then the second is to always
In
minimize to
EMTP, we
system
can
tray
model the
instead of the
detailed
taskbar.
modeling of
With
the
these two
CTs,
settings, you are
VTs,
able to have a
and power
full clean
transformers
capture
with
that
their
wouldn't even
saturation
show any
characteristics
sign
and
that the screen is
hysteresis
being captured.
components.
And that
In
is it for the
EMTP, we
general
can
settings.
able to
Next is the stream
calculate the
settings. Here
different
you
types of
basically need to
ferroresonance
select your stream
analysis
service
like
from the drop down
chaotic or
and then
achaotic
connect
mode
your
of the
streaming account
ferroresonance
appropriately.
phenomena. In EMTP, we can able to
Then you have
model
the
the
output
detailed
settings.
modeling
Here
of the
again,
power
don't tamper with
electronics
any of
and
these settings.
FACTS
Just go
controllers.
down to where you
Here
have the
you can
recording
able to
format.
see the
Use the drop
by
down and
using
change the
EMTP
format to
software.
MP4.
In EMTP, we have
Now by
SVCs,
default, the
STATCOM,
recording path,
IGBTs
which
are
is where the
available.
captured video
We
files
are
are
able
saved on your
to model
computer,
the
is
detailed
your
modeling
Windows
of a
video folder.
STATCOM
This
and
is
its
normally a good
control. All
location,
the
but if
IGBTs
for
we
some
can
reason
model
you want
in
to change
detailed
that, you
manner.
can simply click on the
Sometimes some
browse button
manufacturers are
and then
used to
select your
provide
preferred location.
some control diagrams of this
Next, you want to
STATCOM
go
and
to your audio
SVC so
settings.
that we
Again, here
can
don't play around with all
incorporate
these
those
options. By
manufacturer
default,
models,
OBS
control
is set to
models
record
into the
any audio from
EMTP by
your desktop
using
and also
channel
audio
available
from the
in the
microphone,
EMTP
which is
software.
basically the audio
Here you
from the
can see the
voice or the
example.
environment. This
Here,
would be
here you
perfect
can
if you are
able to see
recording
the
voiceover or making
reactive
commentary over
power
live stream
absorbed by
or
the
capturing your
STATCOM
gameplay.
and the
However, if you
voltages
want
at
to
the
have only
capacitor
the
bank.
audio from your
Like that, you can
computer and
able
no other
to
sounds from the
do the
environment,
real
then you want to
configurations and
go
real
down to this
analysis
mic
with the
stroke
manufacturer
auxiliary
models.
audio
Also, it is possible
and change
by
it from
using
default to
EMTP
disabled.
software.
And that is it for the audio settings. Next, go to the video settings.
Next
Here you
one
have
is
two
HVDC.
resolutions to set up. First
This
is
is
your
a
base
very
resolution,
interesting
which is the
thing to
resolution of the screen you
simulate
are
the
capturing
HVDC
from.
system in
By
EMTP
default, mine is on
software.
1920
In
by
EMTP,
1080,
we
which
have
I
a
highly
generic
recommend
and
for a screen
complete models
capture.
of MMC
Lower
are
resolutions
available
will
here.
obviously
In
offer
this
you lower video
example,
quality,
you
so
can
pay
able
attention
to
to that.
see the
The
MMC
second
level of
resolution is the
400 level.
output resolution,
In
which
this
is the resolution of the
in
captured
EMTP,
video.
we have a
Here again, I will
different levels
recommend you
of
keep it to
MMC
1920 by
modular
1080.
multi-level converters are available in EMTP software.
Then under
And we have an
downscale
average
filter,
value
I
model
normally put
and
mine to
detailed
Lanczos
models
with
of
32 samples.
MMC are available. According to our requirement
Then for
and
the
our
FPS, I
preciseness,
normally leave
we
mine at
can
30
model the
frames per
MMC
second.
according
This is
based
enough
upon
to
our
give a very good
requirement
quality
itself.
smooth video without putting a lot of pressure on your graphics processors. Of course, you can set yours to 60
This
frames
is
per
the
second
example
if
for
your
the
computer is
transient
powerful
stability
enough to handle
analysis.
that.
In this
And then under
example,
the
you
hotkey
can
settings
able
and
to
the
see
advanced
the
settings, I don't
synchronous
normally
machines
change
connected
anything.
to
I
the
leave all the
AVRs.
settings as defaults. Then
In this
finally hit
example,
apply to save all these
after these
changes and
synchronous
then hit
machines are
OK to
connected
close
to
the
the
settings
long
page.
transmission lines, finally it is connected to
Next is
the
to define what
equivalent grid.
element of your
In
display
between
you
the
want to
grid and
capture.
synchronous
For that,
machines,
under
there
the
is a
source tab,
generating
click on the plus
stations
sign to reveal the different
and with
elements you can capture.
equivalent
Here, I just
impedance
want to
values.
capture my full
And here
screen.
we are
That's
creating the
everything that is
fault
visible on
and
the screen.
see the
So I'll
transient
select
stability
display
of those
capture.
synchronous machines.
Here, I will
Here
leave the
in this
name at
waveform, you can
Trigody
able
to
to
download
see
and
that we
install.
are
But
creating
with
the
this,
fault at 0.5 seconds and we are
now when you
reclosing
run
the
the
breakers
OBS for the first
sometimes.
time, it tries
Finally,
to
we
help
are
you set up
opening
the
the
tool by
breaker
using the
connected
auto
to this
configuration
synchronous
wizard.
machine
For this
D4.
tutorial, we'll be
So
skipping
after
that.
that,
So
you can
here I will
able to
hit
see
no.
the transient stability of the synchronous machines
Now,
remain in
without touching
synchronous
any
machine,
settings
and
on
when
this
it reaches
screen,
to the
just go
steady
ahead and
state
click
like
on the
this, you
settings
can
at the right hand
develop
corner.
you can analyze the transient stability
You should
analysis
have
of the
this settings
synchronous
page pop
machines
up.
also.
Here we are just going with the minimal settings for optimal performance. We'll go from top to bottom. So first here we
And
have
in
the
the
general
AVR
settings.
loops, we have
Here you first
exciters,
select the
governors,
preferred language
PSS.
from the drop
There is
down.
a sub-circuit created
Next
and
you can
connected
choose a
in the
theme of your
AVR.
choice.
Here
Here
you
we
can
mainly
able
have the
to see
light and the
the
dark themes
sub-circuit of
with two
exciter
in-between
here.
modes.
And we can enter the parameters in this masked sub-circuit. Similarly, this is
Now
the
leave
example for
everything
the
else as they
governor
are and go down
control.
to the system
In
tray.
EMTP, we have
Here
a
you want to
control
check these
and
two
control
options.
function
First is to
library
minimize
is
the OBS
available. By
recorder to
using
system
those
tray
control
when
functions
recording.
library, we
And then
can
the
able
second
to
is to
develop
always
our
minimize to
customized
system
model
tray instead of the taskbar.
according to our
With these two
requirement.
settings, you are able to have a
Similarly, this
full
is the
clean
example
capture
for the
that wouldn't
governor
even
model
show any
by
sign that the
using the
screen is being
control and
captured.
control
And
functions
that is it for the
available.
general. If you want
In
to change
EMTP,
that,
we
you
have
can
two
simply
types
click
of
on the browse
transformers are
button
available for
and then
detailed
select
modeling.
your preferred
DC
location.
chan and relay model. By using those transformers, we can able
Next,
to
you want to go to
energize the
your audio
transformers
settings. Again, here don't
in
play around
detailed
with
way.
all
If we
these
don't
options.
have
By
the
default,
detailed
OBS is set to
parameters,
record
so
any
that we
audio from
can
your
able
desktop
to
and
add the
also audio from
saturation
your microphone,
characteristics
which
in
is
the normal
basically the audio
transformer,
from
and
the
we can
voice or the
energize the
environment.
transformer with
This would be
different
perfect if you are
configurations and with
recording
different
voiceover or
scenarios.
making commentary over live stream or capturing your gameplay. However, if
Here
you
you
want
can
to
able
have
to
only
see the
the audio
different
from your
scenarios
computer
of
and no
the
other sounds
transformer
from the environment,
energization with
then you
and
want to
without
go down to
residual
this
fluxes
mic
with
stroke
different short
ancillary
circuit
audio
powers and
and change
breaker
it from
closing
default to
time.
disabled.
According to the closing time of
And
a
that is it for the
breaker,
audio
there is
settings.
a change in the inrush
Next,
current
go to
peak
the video
values so
settings.
that
Here you
we
have
can
two
able to
resolutions
study
to
the
set up.
transformer
First is your
energization
base
studies in
resolution, which is the
statistical
resolution
analysis
of
by
the
using
screen you are
statistical
capturing from.
analysis
By default, mine is
to
on
find the
1920
worst
by
peak
1080,
values.
which I highly recommend for a screen capture.
Here you can
Lower
able to see the
resolutions will
inrush
obviously
current
offer you
occur in the
lower video quality, so
transformer
pay
for
attention to
different
that.
configurations
The
with
second
different
resolution is the
scenarios.
output
And
resolution, which is the
similarly, you can
resolution of the
able to see the
captured video.
voltage at
Here
11
again,
kV
I would
bus.
recommend you
Here
keep
you
it to
can able to
1920
see the
by
voltage
1080.
drop at the time of transformer energization
Then under downscale filter, I normally put mine
with
to
different
Lanczos with
scenarios.
32 samples. Then for the FPS, I
Next,
normally
this
leave
is the
mine at 30
example for
frames
the
per
wind
second.
generation.
This is
In this
enough to give a very good
example,
quality smooth
normally
video
if we are
without putting a
connecting
lot
the
of
wind
pressure on your
and
graphics processors.
PV
Of
panels
course, you can
into
set yours to
the
60
grid
frames per
system,
second
there
if
may
your
be
computer is
then
powerful
we
enough
have
to handle that.
mainly look on to the
And
power
then under the
quality
hotkey
issues.
settings and the
Here you
advanced
can
settings,
able
I don't normally
to
change anything. I
do
leave
the
all the settings as
wind
defaults.
parks and
Then
PV parks
finally
into
hit
the
apply to save all
harmonic
these
current
changes
source
and
model,
then
and
hit
we
OK
can
to
able
close the
to check
settings
the
page.
harmonics values compared with the IEEE
Next is is to
standard
define what
519.
element of your display you want to capture. For that, under
In
the
this
source tab,
example,
click
you
on the
can
plus
able
sign
to
to reveal
find
the
the
different
harmonic at the
elements you
time
can
of
capture.
harmonic order
Here, I just
22.
want to capture my
We are
full
getting the
screen.
high
That's
value of
everything that is
harmonics
visible on the
compared with the
screen. So
IEEE
I'll
standard
select display
519,
capture.
so that we can able
Here, I will
to
leave the
add
name
the
as display
filters, some
capture. You
type of
can rename it
filters
just
at
as you
some
wish,
places
and
to
then
minimize
hit OK.
those harmonics. If we
Now, as
want
soon
to
as you
model
do that,
in
you will notice
detail,
that your
then we
current
can
display is
create
ready to
a
be captured.
fault
Now, if you
at
have
the time
multiple
of 1
displays and you want to
second, and
select
we are
some other
clearing
display,
the
then you
fault
can
at
use this drop down
1.2
to do
seconds
that.
here, so that
Then
we
hit
can
OK
able
once
to
again,
see the
and you are good to
PN
go.
view of the
Here it
wind
shows you
paths
a preview of what you'll be
changing, and
capturing
we
whenever
can
you click
measure
to
the
capture.
voltage
So here, when
VRMS
I
at this
minimize the
bus 1.
OBS, everything about it disappears. To start recording, I will simply go to my system
Sorry.
tray. right click on the OBS icon and select start recording.
Yeah.
And then I have this red dot
Like
showing
this, we
that the
can
screen is
simulate the
currently
wind
being
generation
recorded.
applications by using in
And
EMTP.
once
We
I'm
have a
done, I
type
go back
3
to the
and
same
type
icon,
4 wind parks are
right
available.
click on it
And
and select
similarly, we
stop
can do
recording.
some integration
And
techniques
shortly
like
after, the red
subsynchronous
dot
control
disappears.
interactions are
Then when
also
I go
used
to my
to
video
develop,
folder,
and we
I will
can see
find
the
the video file I
subsynchronous
just
control
recorded.
interactions by using EMTP software.
Here, as you can
This
see,
is
it's almost
in each
impossible to
and
differentiate the
every
capture
wind
screen
park.
from the actual
Here you
screen,
can able to
except
see
when
the
you move your
complete
mouse
wind park
around the
model.
player
This
controls.
wind park is connected to the arrestor and fuse here. Each and every component of the wind park is connected like this,
Now,
and we
there are
are creating
tons
the
and tons of
sub-circuit there.
features and settings you can
This is
play
the
around with
complete
on the
wind park
OBS.
model is
This is
available.
just what I consider the
Here you
most
can
basic
able to
settings
see
for
the
a
pitch
clean,
angle,
smooth
what is
screen
the
capture
converter
using the
control
OBS.
and DFIG
And that is it for
control.
this tutorial. Give this video a thumbs up if
Asynchronous
you
machine
found it
connected to
useful.
the
Share with
turbine.
anyone you think might
All the
want to
things you
see.
can able to
Drop us a
see
comment if you have any questions or
directly in
feedbacks. Don't forget
EMTP
to
software. For
subscribe and
each and
turn on
every component
notification for
sub-circuit
updates
we
on
can
future
able
tech
to
support
open and
videos
we
like
can
this one.
analyze the
Thanks for
sub-circuits,
watching and
and
see you in the
if
next
you
one.
want to modify that one, you can modify that one also. This is the EMTP RB WindPark benchmark model is available in the EMTP software. In this example, there is a connection of
Welcome
offshore
to
wind
Learn
parks
It
and onshore
Anytime
wind parks,
Windows 10
synchronous
training.
machines, and
I'm David
HVDC
Lieberman, the
transmission
Vice
line. All
President
are
of
connected,
e-learning
and they
here
are
at Learn It
able to
Anytime.
creating
I
a
wanted
fault
to take a
and
second to let
see
you
the
know that we
transient
also
stability
deliver
responses
excellent
from the wind
training in
parks.
other software, like MS Office
This is
programs,
the example for the
Excel,
subsynchronous control interaction. Normally, the subsynchronous resonance is occurred when there is an interaction between the wind turbine generator and the series compensated transmission line. Here, in this example, we are creating a fault on the first transmission line at 2 seconds, and we are opening the breakers at 2.1 seconds. That means we are disconnecting this first line at 2.1 second. After 2.1 second, this wind turbine generator is connected with the series compensated transmission line, so that it is able to generate some subsynchronous resonances, and because of that there is a high current is available with low frequencies. Here in you can see the waveform, and you can see the frequency response as a 24 hertz. Like this, we can able to see the subsynchronous control interactions also by using EMTP software. Now we can enter into the protection examples. Here you can able to see the example of overcurrent protection. Normally, in all the time domain softwares, we can able to perform the overcurrent protection and other things in only steady state analysis. In that, we can able to see the responses of zero sequence currents and positive sequence, negative sequence currents, and accordingly we can see the relay tripping time itself. In EMTP, the advantages we can able to study the protection or current protection and other things in time domain analysis also. In this example here, you can able to we are creating a fault at 0.5 seconds, and we are opening the breaker due to the fast neutral protection. After we are again closing the breaker, again opening the breaker, and again by using slow neutral protection. Like this, you can create you can see the overcurrent protection, what happened in the time domain simulation directly you can see. This is an example for the differential protection. Normally in here we are using the transformer differential protection connected to the differential relay. At the time of transformer energization, there may be a chance of induced currents. Due to those induced currents, there is a flow of differential current through that relay. So to avoid the relay operation at the time of transformer energization, we need to calculate the second harmonic value. Here you can able to see the responses of CT secondaries and the differential current flow through the relay. So to avoid the differential relay operation at the time of transformer energization, we are able to calculate the second harmonic inhibit functions, and we can able to take those value as a inhibit the harmonic function in the differential relay to avoid the relay tripping at the time of transformer energization. In EMTP, we can perform the calculation of FFT analysis, and we can calculate the harmonic components directly by using scope view. This is the example for the distance protection. In this example, we are creating a fault at this bus and we have to see the current flowing through the breakers at the time of a fault. And if you want to see the response in RX graph so that in EMTP it is possible to see the zone, at what zone the fault is created and what is the zone expansion, you can directly see by using EMTP software scope view. Similarly, we can model the power swing and out of phase detection by using EMTP software. This is the example for harmonic analysis studies. In this example, we are calculating the harmonic components and different harmonic orders. We can compare those harmonic values with IEEE 519, and if we can, in this example, we can perform the frequency scan analysis. You can compare these two. Here we are getting the at 3 kilohertz, nearby 3 kilohertz, we are getting the resonance value. Here you can able to see the at the time of a near 50th harmonic order and 48th harmonic order, you can able to see the higher harmonics compared with the IEEE standard 519. Like this, we can create different applications and different things in EMTP software very easily. Now we can go to the EMTP software and we can do some examples in the EMTP software by hands-on. We can provide. Just you can, in the start menu, just you can type the EMTP works. Parallelly, you can also do the examples. Just can you please open the EMTP software by clicking on the, in the start menu, you can click on the EMTP works and click on the EMTP works. Now you can able to open the EMTP software. Now you can see this is the EMTP GUI here. If you want to open the existing file, then you can directly browse from here. If you want to open the recent files, then you can directly open a recent file. And we have a lot of example files are available in EMTP software. Here you can able to see the different examples related to the ferroresonance, HVDC, and some IEEE standard examples, lines and cables, load flow analysis, TRV analysis, different and renewables protection. You can able to see the different examples in EMTP software. If you want to create a new default design, you can use here or here. Just you can click on the new page and click on the EMTP default design and create. I hope all the people are doing the same thing in your laptops parallelly. Just you can open the new page, new document. You can find this. After that, just you can save the file. First, I can take the example of a simple RLC circuit creation in the EMTP and save. This is the EMTP GUI available. You can do the all simulation modeling, design modeling here. And on the right side, you can find the different library parts available in the EMTP software. From the right side, I'm going to the RLC branches. Just you can double click on the RLC branches. Drag and drop the RLC parameter components one by one. R and L. Similarly, you can take the capacitance of non-polarizer like this. Just you can drag and drop the R, L, and C components from the RLC branches. After that, just you can go to the sources library and take the AC voltage source single phase. Now you can connect this AC voltage source to this R. Directly just you can drag the signal. You can draw the signal like this. To connect this capacitance, just I am added one more switch here from the switches library. Ideal switch you are taking or ideal switch breaker symbol, anything is same, both are same. Just you can connect like this. After that, you can connect the capacitance to that switch other end. After that, you can connect the ground on both sides from source and at the capacitor side. Just I can explain once again. You can take the RLC components from the RLC branches. You can take the RLC R, L and C non-polarizer. From the components you can drag and drop. After that, from the sources library, just I am taking the AC voltage source. You can drag and drop that AC voltage source into the EMTP GUI. Just you can drag and drop here. I can mark it. After that, for connection of this capacitance, I am added as this switch from the switches library. I am taking the ideal switch. Just you can drag and drop that ideal switch into GUI and you can connect the complete RLC circuit like this. Hope all are completed this RLC circuit connection. Now just you can double click on the voltage source and change the voltage to 11 kV and frequency to 50 Hz. To enter the parameters into the components, just you can double click on the component and you can enter the voltage as 11 kilovolts and frequency as 50 Hz and click OK. Similarly, you can take the R value as some 5 ohms and change the frequency to 50 Hz. Click OK. In inductance, you can enter the inductance as a 5 millihenries and change the frequency to 50 Hz and click OK. Just you can double click on the switch. I am closing this switch at 10 milliseconds and never open. Just I am closing the switch connected to that capacitor is I am closing at 10 milliseconds and never open and click OK. Now you can go to the capacitance and enter the capacitance as some 3 microfarads and change the frequency to 50 Hz and click OK.
Ma'am, can you repeat the one time?
Okay, just you can double click on the each and every component. Just you can double click on the voltage source and change the voltage to 11 kilovolts and frequency to 50 Hz and click OK. After that, you can in the resistance double click.
Madam, What is the ground? Ground, where is the ground?
In the switch RLC branches and in the sources library also you can find the ground. In the sources library, there is a ground is available. Just you can drag and drop and you can connect to the voltage source and capacitance here.
Madam, where is the switch?
I can explain again the complete thing, okay? Just you can follow. I can see the I can see you can go to the RLC branches. Just you can drag and drop the R, L, and C. Non-polarized you can take. Similarly, from the sources library, you can take the AC voltage source. Just you can drag and drop into the GUI. Then from the switches library.
Monica, go a little bit slow, otherwise participants will not go that much fast. Okay?
Okay, sir.
Yeah, it's a hands-on session.
From the switches library, you can take the ideal switch. You can take the ideal switch into the GUI and you can connect all these components like this in this circuit. For the ground, you can go to the sources library. There is a ground is available. So you can drag this ground to connect the voltage source and the capacitance. For the connection, just you can directly connect the general signal.
Can I connect the ground as a one?
In sources library, there is a ground is available. Just you can drag that ground.
Yes, ma'am. I know this, but I want to drag the set as a ground as a one. By
Hello?
ma'am.
Yeah, tell
I
me.
want to set. I want to set the ground as a one plus of two.
Yeah, that
Yeah,
up to you. Okay. Yes of now, you can follow the procedures now currently. Okay. If everyone keep asking questions, it is very difficult to answer all the questions. Okay. So you can please follow the instruction what he is saying. Okay. Initially. Yeah. Thank you. Monica, you can continue.
Yeah, okay, sir. Just you can drag and drop that ground and you can connect like this. After connecting the circuit, I can say again the values. You can double click on the voltage source and enter the voltage as 11 kV and frequency to 50 Hz and click OK. For the resistance, you can enter the resistance as 5 ohms and click OK. Similarly, for inductance, 5 millihenries I am added and change the frequency to 50 Hz. For capacitance, I added the capacitance as 3 microfarads and frequency to 50 Hz and click OK. After that, just you can go to the switch and you can add the switch closing time as a 10 milliseconds and opening time is never open. Just click on the never open and click OK. The resistance value is 5 ohms, inductance value is 5 millihenries and capacitance value is 3 microfarads. Hope all are connected this circuit. Now to see the output responses, we can add the meters. Just you can go to the meters library, take the voltage scope 1 pin, go to the meters library and take the voltage scope 1 pin. Just you can drag the voltage scope 1 pin to here and you can connect like this. To see the output voltage response, here I am connecting the voltage scope 1 pin, which is available in the meters library. Just you can go to the meters library and take the voltage scope 1 pin and you can connect like this. If you want to see the output response of the current flowing through the capacitance, so you can double click on the switch. For each and every component, there is a scopes tab is available in EMTP software. So you can go to the scopes tab and enable the current and click OK. To see the current flow through the switch, just double click on that switch, go to the scopes tab and enable the current. Then only the currents will be available in the scope view. After that, you can click OK. After the completion of that, just you can go to the Simulate tab, Simulation Options.
Simulation.
Go to the Simulate tab, Simulation Options, and you can change the main time step to 10 microseconds and simulation time to 100 milliseconds. Go to the Simulate tab, Simulation Options. You can click on the Simulation Options. Just you can change the main time step delta t to 10 microseconds and simulation time t maximum to 100 milliseconds. And change the default frequency to 50 Hz. And click
I can't
OK.
find the simulation option. Where is the simulation option?
This one. Just you can go to the Simulate tab. There is a simulation option is available. After the Run button, there is a simulation options. Just you can click on that simulation options. Change the main time step delta t to 10 microseconds and simulation time t maximum to 100 milliseconds and click OK.
Hello?
Sorry. Yeah. After completion of that, just you can run the simulation.
వీడు మళ్ళీ కొట్టుకడిపోయినావా
Just run the simulation. To see the output responses of this current and voltage, just you can go to the Simulate tab, click on the View Scopes with Scope View. Just you can go to the Simulate tab. After completion of simulation or after clicking on the Run button, just you can go to the Simulate tab. Click on the View Scopes with Scope View.
Ma'am, doubt.
Just you can go to the Simulate tab and click on the View Scopes with Scope View. You have two windows are available. One is a signal window, another one is a signal graph
Ma'am,
window.
once more, ma'am.
Yeah, sure. After connecting the voltage meter and current, enable the current in the Scopes tab of switch 1, just you can go to the Simulate tab.
I'm unable to see, ma'am.
Just you can go to the Simulate tab. Simulation Options. You can change the main time step delta t to 10 microseconds.
Think not.
T maximum to 100 milliseconds. And change the default power frequency to 50 Hz and click OK. After that, you can run the simulation. There is a Run button is available in the Simulate tab. Just you can run the simulation. To see the output responses, just you can click on this view scopes with scope view. After clicking on the view scopes with scope view, you have two windows are available. One is this is the signal window. Another one is a signal graph window. Now you can go to the signal window. Here you can able to see the signal type. Initially it is a node voltage. Just you can click on the drop button. Then you can see the different voltage, different things here, signal types, node voltage, switch current, or if we are enable the branch current, then it is also branch voltages are available. Now I can able to click on this M1 at the rate of Vn. This M1 represents the name of that component. Here you can see the voltmeter name as M1. That you can see M1 at the rate of Vn. That means it will provide the output as a node voltage so that you can able to see at the rate of Vn here. If it is a branch voltage, you can see Vb. If it is switch current, then you can able to see Is. Like that, it is represented in EMTP scope view. So just you can click on that voltage. Just you can click on it. Automatically, it will come into this window. After that, just you can go to the signal type as a switch current. And click on the switch 1 at the rate of Is. Switch current flowing through this switch. Here the SW1 is the switch name. Yes, I can explain again once more. After opening the scope view, in the signal window, there is a signal type node voltage switch current is available. Just you can click on the node voltage. In that you can click on the M1 at the rate of Vn signal. Enter the conductor data. This conductor data we can enter from the transmission tower configuration. From this tower configuration, we can calculate the horizontal and vertical distances. We can able to enter those values into the line data. Like this we can model. In EMTP, we have a default database is also available. Just you can click on the use database. Just you can click on that line data, double click on the line data. This conductor data parameters is available. Here I am taking the default database available in the EMTP library. Just you can go to the use database, click on this use database. Here with different configurations like single circuit or double circuit with different voltage levels, the database is available. Here I am considering the 400 kilovolts ACSR single circuit line for this configuration and click OK. So all the parameters are automatically coming to this conductor data available in the line data. Again, I can explain. Just you can click on the use database. From that you are taking the 400 kV ACSR single circuit and click OK. Automatically the parameters are coming to this conductor data tab. If you have an additional data like skin effect corrosion and bundle conductors, then you can enter those values. From here, automatically the 400 kV ACSR single circuit from the default line database. Okay. In that there are two bundle automatically the parameters are coming to this conductor data tab. If you have an additional data like you can go to the model skin effect corrosion and bundle conductors, change the line model to frequency dependent model, FD model. Here you are taking the model indicators ACSR single from the default line database. In that there are two bundle automatically the parameters are 45 centimeters. Conductor data change. Select the model type as a frequency dependent model. If you have an additional data like you can go to the model skin effect corrosion and bundle conductors. After that you can go to the line dependent model FD model and change the automatically the model indicators ACSR single from the default line database. In that there are two bundle automatically the parameters are 45 centimeters. Conductor data change. Select the model type as a frequency dependent model. If you have an additional data like you can go to the model effect corrosion and bundle conductors. After that you can go to the line dependent model FD model and change the automatically the model indicators ACSR single from the default line database. Here you can able to see automatically the generators are 45 centimeters. In the console library you can able to select the model type the file parameters are calculated here. If you want to see the additional data, you can go to the model corrosion and bundle conductor. After that, you can go to the line dependent model, FD model, and change the automatically the model indicators ACSR single from the default line database. You can see automatically the generators are 45 centimeters. In the console library, you can select the model type of file parameters transformation current transformation matrix. If you want to see the additional data, you can go to the model corrosion enable after that you model go to the line dependent model FD model change
Please repeat that line model specification.
ACSR single from the default line database. In the automatically the generators are used data in the console library. Select the model called the file parameters transformation current transformation matrix. If you want to see the additional data, you can go to the model corrosion enable after that you model go to the line dependent model FD model.
Please repeat that line model specification.
Select the model type as a default line database. In the automatically the generators are used data in the console library. Select the model called the file parameters transformation current and select the model. If you want to see the additional data, you can go to the model corrosion enable after that you generate the line dependent model FD model.
Please repeat that line model specification.
Select the model type as a default line database. In the automatically the generators are used data in the console library. Select the model called the file parameters transformation current and select the model. If you want to see the additional data, you can go to the model corrosion enable after that you generate the line dependent model FD model.
Please repeat that line model specification.
Select the model type as a if you want to see the in the automatically the generators are used data in the console library. Select the model called the file parameters transformation current and select the model. If you want to see the additional data, you can go to the model corrosion enable after that you generate the line dependent model FD model.
Please repeat that line model specification.
Select the model type as a if you want to see the in the automatically the generators are used data in the console library. Select the model called the file parameters transformation current and select the model. If you want to see the additional data, you can see the model
We have the different line lengths. Please repeat that line model we have the different line lengths.
is imported into this frequency dependent line and click OK. Just I can explain once again. Just after generating the data from line data, to import these 100 kilometers line parameters into the, like this, you can import the line parameters into the transmission line model directly. After getting this, just you can click OK. In EMTP, for each and every component, there is a help documentation is available. For this line data also, just you can double click on that line data. There is a help tab is available. Just you can click on that help tab. You can able to see the for each and every tab, there is a help is available. Hello?
Ma'am, can you explain for transmission line again?
Yeah, sure. From the lines library, just I can explain again. From the lines library, you can drag and drop the line data. Double click on this line data. Go to the use database and select the 400 kilovolts ACSR single circuit and click OK. After that, go to the model tab and change the select model to frequency dependent model and change the line length to 100 kilometers. By default, the ground resistivity is 100 ohms here. I didn't change that one. After
Good
that,
grammar and spelling are important. But if you want to write essays that inspire, messages that forge brighter connections, and emails that get the job
After
done,
that, you can drag and
you
drop
need
the
to think
frequency
about more than
dependent
just
line
grammar and
available in the
spelling.
lines library because
This
I modeled
sentence
this line
is
data 100
grammatically
kilometers
correct,
as a frequency
but
dependent
it's wordy
line.
and
So
hard
you can
to
drag
read.
and drop this
It
frequency
undermines the
dependent line
writer's
into
message,
GUI.
and the word
Double
choice is
click on this
bland.
frequency dependent line.
Grammarly's cutting-edge
Then select the
technology
data
helps
file.
you craft
Whatever you
compelling,
save the file name
understandable writing
in line data.
that makes an
Just you
impact
can
on your
click on
reader.
that 100 kilometers and open the file
Much better.
and click OK.
Grammarly works where you work, on your computer or your phone. Imagine
line
what you
data,
could do with the secrets
each
of
and
the
every
world's
component,
best
we have a
writers
help
at your
help
fingertips,
tab is available.
anytime you need them.
You can
Are
go
you
to
ready
that
to give it a
help
try?
tab. For each and
Installation
every
is simple and free.
tab, there is a help
Visit
documentation is
Grammarly.com
available
today.
here. Just you can click on that conductor data. Here you can able to
Hi guys, this is Daniel from FND. In this
muted every component in EMTP. Hope all are model this frequency dependent line. now we will take a break for 15 minutes and we will come back within 15 minutes. Okay. After that, we will go for the this transmission line energization. From that, we can go for the wind. We can add the wind generators. Hello.
Hello, madam.
Yes. Hello. Yeah.
No, I
hello.
am. Just now I listened your topic, ma'am. I am unable to open the software. Ma'am. How to open this one? My laptop.
So I think
Hello?
there may be some Windows update issue is there. Can you please check your Windows update?
EMTB works. Icon
Yes,
is was there.
Yeah, you can click on the EMTB works. Just
okay, madam. After clicking the
just 1 second, sir.
Hello.
One second, sir. The remaining people, if you want to go for a break, just you can go for a break and we will come back within 15 minutes. Yes, sir. Now you can tell me.
The EMT, I click on EMTB works, ma'am. It's showing please use the EMTB activation utility to install or update your license then restart the program.
Okay, sir. In the EMTP activation utility, I think you received the license file yesterday. So just you can import that license file in the EMTP activation utility.
Excuse me, ma'am.
I already shared the text file with you. Okay. Please check your email attachments. Okay. Download the license file and just go to EMTP activation utility and click import license file. The details also specified in the attached installation manual. Could you please check? Okay.
Excuse me, sir.
Excuse me, ma'am.
Hello.
Okay, you go ahead. I will try once again and I will.
Okay, sir, you can try.
Excuse me. Okay, sir.
Okay. Like that we can try. Otherwise,
Okay,
you
sir.
go to Windows Update. If still not coming, you go to Windows Update and check for your Windows Update.
Okay, sir.
Okay. Yeah, Monica.
Hello.
Hello.
Hello. Yes, sir. It's still not opening, sir.
Please check for your Windows Update, sir. Yeah.
If you
Sir,
write
I've checked. There
anything
is no.
on your
It's all
computer,
updated,
you
sir.
need to
There's
get
no
Grammarly.
update.
I write pretty much all day, every day, and Grammarly makes my writing better.
As a student, I like that it's free. Actually, it's
Then you go
correcting
to
everything as I'm writing.
Grammar errors, spelling errors.
Hey guys,
Yes,
Tropics
sir?
here, and welcome back. In today's video, I will be showing you guys some potential fixes on how to fix the
Okay,
black
yes,
screen
sir.
for OBS. Now, I've been getting so many
C
freaking
drive.
comments and
Okay, sir.
Program files 86.
Program files. Okay.
Not program files. Program files x86.
Okay, sir. X86.
There you can find folder EMTP works
1 second,
4.1.
sir. No, sir. It's not here.
No, not program files. Program files 86.
Yes, sir. 86 only. It's not there.
No, you should be installed in your program files. I think you have not installed properly in Do you find a program files 86 in your computer?
Yes, sir.
There you can find EMTP work 2.1 or 2.0 like that.
Sir, I've installed it in D drive, sir, not C drive.
Then you go to
D drive I found.
there you can go to EMTP works and there is a folder called scope view.
Scope view, okay, sir.
And there you can open scope view application. Double click.
Scope view application. 1 second, sir. Sir, I have double clicked.
Okay, it may ask for some pop-up message to allow access. You can click allow access.
Just a second, sir.
Sir. Hello, sir.
Yeah, yes, scope view is open.
Sir, when I'm going to click on lines, I'm not getting these options.
Which option?
Yes, sir, it's open.
Sir, when I'm clicking on the lines in parts of library here in lines, I'm not getting these options like cable data, Corona, CP out circuit line. I'm not getting these.
Okay, what you are getting?
When I'm just clicking on the lines, it's showing me read only RLC branches here. Means it's showing me read only. Means I'm not getting any options.
No, it's no. You are not in somewhere. I couldn't be able to check it.
Sorry, sir.
I couldn't.
That means you are not properly installed.
Sir, that scope view application is open, sir. After that, what I'm supposed to do?
In scope view, file open.
Yeah, file open.
You go to the location where you have saved your EMTP file. And save your file name on folder is there with addition of underscore pj. You go to that folder. Monica, you prepared any documentation for this option? Okay. Okay, if it is there, we can attach the document here and ask them to download it. So, okay, no issue, you can continue. Yeah. You can start now session. Yeah. Okay, okay.
Sir? Sir?
Hello. Madam, I
Sir?
am unable to install.
Yes, yeah.
As per as per manual, I was installed, sir. While installing that, what can I say, EMT utility, what you given the link, that is different, this is different.
Hi guys, Eggy here, and today I'm going to show you how to do a window capture for Open Broadcaster software. A window capture is a source option for your scenes that lets you capture and for you to manipulate your window capture. Now right now I have no options. Even if I hit refresh, I have no options. But I will pull up my Google homepage pulled up. I'm going to mouse flicker, yes, and then everything, and then well, the average video on the window page. To my other tab, my grievance home.
After that, Just double click on the voltage source and impedance.
Sir, I want help, sir. I want internet for this. Coming, sir. Only the problem is the systems are not
EMTP software. I'll explain again how to open that example. Just you can go to the file tab. There is an example file. Open an example file in the options tab. Just you can go to that. You can double click on this application cases. You can drag. There is a lines and cables tab is available. You can double click on this lines and cables. In this, you can take the double click on the energization with arresters. There is a model file is available here, line energization.ecf. You can click on this. Then click on this open example.
internet problem. I want internet.
After that, it is asking for some message. So you can click on this OK. Now here I am getting the example file of line energization available in the EMTP software. In this, I have a ZNO data function is available for 400 kV 360 kV arrestor. So I can copy this ZNO data function data. Further, just you can click on this ZNO data function. You can click on this ZNO data function, right click. There is a copy or paste option is available. From here, you can copy the data. Then go to your line model. From the example file too, you can go to your line model and click on this ZNO data function what you have added in the GUI and right click. You can paste the data. Now you can double click on this ZNO data function in your line model. You can able to see the VI characteristics of the surge arrestor.
Morning onwards, I didn't write this one.
Here you can able to see the data voltage rating and desired voltage rating. Here the VI characteristics we have entered for the data voltage rating of 96 kilovolts arrestor. EMGP automatically calculated those 96 kilovolts arrestor into 360 kV arrestor. And after that you can click OK. It is asking for calculate or recalculate the model data from this device. Then you can click OK.
So my internet is also not sufficient, huh?
Then it is ended. That means
Video is not.
the parameters are ready to enter the. We need to import the parameters into this arrestor. Further, just you can copy the data again. ZNO data function. Click on that and copy the data and paste the data into arresters. Just click on the ZNO arrestor. Right click. Paste the data. Now you can see the data is pasted into this ZNO arrestor from ZNO data function. And click OK. Similarly for this side also. For the sending end side also, you can paste the data into the arrestor. I can explain again. From the example of line energization, just you can click on this ZNO data function, right click. You can copy the data, go to your line model, click on this line model tab. Here you are added the ZNO data function before. Further, you can click on this ZNO data function block and right click, paste the data. After double click on this ZNO data function, you can click OK. It is asking for the recalculate the model data from this device. Then you can set OK. Now it is EMTP automatically calculated and here the program is ended here. Now again you can copy the data from ZNO data function and you can paste it into arresters. You can paste the data in both sides of transmission line arresters. Like this you can connect the arresters and you can model the arresters here.
Current is there?
After the completion of this, just you can click on this run data
bar at the bottom
in the simulate tab.
OBS
You can click on that run.
broadcasting. You need to check there.
You can run the simulation and click on this view scopes with scope view. You can click on the view scopes with scope view. It is already open for my case. Just you can run the simulation again. Now you can able to see the maximum values as for the receiving end voltages. Before I am getting 1150 kilovolts around. Now after connecting the surge arresters, it is reduced to 759 kilovolts. Like this, we can add and we can reduce the switching transients by using surge arresters.
Sir, I am recording the screen, sir. Correct. That should come in the YouTube.
After connecting the surge arresters on both sides of the transmission line, you can import the data into ZNO data function and to the ZNO arresters. You can run the simulation again.
Live is recording.
After run the simulation,
They muted all the
just you can go to the view scopes with scope view
post
and click on this play button.
voice only comes to others. What we speak, it won't come.
Here you can able to see the maximum value of receiving end voltages. Before with the trapper charges without surge arrestor, I am getting the maximum value as 1100 kilovolts. Now you can able to see the voltage as 759 kilovolts.
Everything I done. Everything we did. Properly all the things are options I done. Still it's not.
I hope all are completed this with surge arresters. You can see the difference without and with surge arresters switching transient magnitudes. Like this, if we add the PIR or point on wave switching, we can able to reduce the switching transients by using these methods also.
All that they do is not coming. Just now came and again gone. Why? I don't know. Again, just now came. Blank screen is coming again. I tried in laptop. Just now, last time, I don't know the reason what is.
Go to the home tab and save the file name as save as with some other name. After the save as, we can save this file as some other name.
I tried in laptop.
Just I am deleting this ZNO data function and arresters, voltmeters. I am deleting this. After the save as, we can save this file as some other name. ZNO data function and arresters, voltmeters. I am deleting this. After the save as, you can save the file name as some other name. Just you can delete the ZNO data function and ZNO arresters, voltmeters. For some other example, I am deleting this. After the save as, you can save the file name as some other name. After that, just you can delete the ZNO data voltage source and here I am connecting one bus. Voltmeter. For some other example, I am deleting this. Just you can go to the home tab After the save as address, you can save the file as some other name. You can drag the pages. You can connect the voltage source, and here you can click on this path reface bus. For some other example, I am doing this. Just you can go to the home tab. After the save as address, you can save the file as some other name. You can drag the pages. You can connect the voltage source, and here you can click on this path reface bus. For some other example, I am doing this. Just you can go to the home tab. After the save as address, you can save the file as some other name. You can drag the pages. You can connect the voltage source, and here you can click on this path reface bus. For some other example, I am doing this. Just you can go to the home tab. After the save as address, you can save the file as some other name. You can drag the pages. You can connect the voltage source, and here you can click on this path reface bus. For some other example, I am doing this. Just you can go to the home tab. After the save as address, you can save the file as some other name. You can drag the pages. You can connect the voltage source, and here you can click on this path reface bus. For some other example, I am doing this. Just you can go to the home tab. After the save as address, you can save the file as some other name. You can drag the pages. You can connect the voltage source, and here you can click on this path reface bus. For some other example, I am doing this. Just you can go to the home tab. After the save as address, you can save the file as some other name. You can drag the pages. You can connect the voltage source, and here you can click on this path reface bus. For some other example, I am doing this. Just you can go to the home tab. After the save as address, you can save the file as some other name. You can drag the pages. You can connect the voltage source, and here you can click on this path reface bus. For some other example, I am doing this. Just you can go to the home tab. After the save as address, you can save the file as some other name. You can drag the pages. You can connect the voltage source, and here you can click on this path reface bus. For some other example, I am doing this. Just you can go to the home tab. After the save as address, you can save the file as some other name. You can drag the pages. You can connect the voltage source, and here you can click on this path reface bus. For some other example, I am doing this. Just you can go to the home tab. After the save as address, you can save the file as some other name. You can drag the pages. You can connect the voltage source, and here you can click on this path reface bus. For some other example, I am doing this. Just you can go to the home tab. After the save as address, you can save the file as some other name. You can drag the pages. You can connect the voltage source, and here you can click on this path reface bus. For some other example, I am doing this. Just you can go to the home tab. After the save as address, you can save the file as some other name. You can drag the pages. You can connect the voltage source, and here you can click on this path reface bus. For some other example, I am doing this. Just you can go to the home tab. After the save as address, you can save the file as some other name. You can drag the pages. You can connect the voltage source, and here you can click on this path reface bus. For some other example, I am doing this. Just you can go to the home tab. After the save as address, you can save the file as some other name. You can drag the pages. You can connect the voltage source, and here you can click on this path reface bus. For some other example, I am doing this. Just you can go to the home tab. After the save as address, you can save the file as some other name. You can drag the pages. You can connect the voltage source, and here you can click on this path reface bus. For some other example, I am doing this. Just you can go to the home tab. After the save as address, you can save the file as some other name. You can drag the pages. You can connect the voltage source, and here you can click on this path reface bus. For some other example, I am doing this. Just you can go to the home tab. After the save as address, you can save the file as some other name. You can drag the pages. You can connect the voltage source, and here you can click on this path reface bus. For some other example, I am doing this. Just you can go to the home tab. After the save as address, you can save the file as some other name. You can drag the pages. You can connect the voltage source, and here you can click on this path reface bus. For some other example, I am doing this. Just you can go to the home tab. After the save as address, you can save the file as some other name. You can drag the pages. You can connect the voltage source, and here you Go to the general tab. Go to the general transmission grid nominal load. Disable this one. Go to the general transmission grid nominal load. Disable this one. If you want to disable the equivalent grid nominal number of wind turbines in service as here my total number of wind turbines is 15. Here I am adding only 12 wind turbines are in operating condition here. Accordingly, the wind park rated power is calculated and we have a different operating condition modes are there. Q control, P control, power factor control and all the things are available. Here I am taking the reactive power control mode. Next you can go to the path transformer. Just I am changing the nominal power to 30 MVA and nominal frequency to 50 Hz and change the grid side voltage to 400 kilovolts. Why? Because here another side the grid voltage is 400 kilovolts. After that, you can go to the inverter transformer, change the frequency to 50 Hz and nominal power to 30 MVA. And this is my converter side voltage I am placing as a C and grid side voltage is also I didn't change that one. So 34.5 by default it is same. So you can click OK. Just I will explain the parameters of wind park.
S3 ma'am.
Just you can double click on the wind park. Yes, sir.
Ma'am, can we get the this enter data by ebooks or e-PDF?
Which one, sir?
PDF. Can you get this?
Yes, sir. We will provide the presentations under this.
Sir?
We will provide the model details here. We can provide documentation and PPTs we can provide. Okay, sir.
Thank you, ma'am.
Just I can explain again the wind park parameters here. Can you please check? Just double click on the wind park, DFIG wind park. Go to the general tab. You can enter the number of wind turbines as 15. Change the frequency to 50 Hz. Here I didn't change the collector grid nominal voltage. It is same as the 34.5 kilovolts. I am changing the transmission grid nominal voltage to 400 kilovolts here because the other side of the voltage source value is 400 kilovolts. So I am changing the voltage to 400 kilovolts. And in the operating conditions, I can change the number of wind turbines in service to 12. Then you can go to the path transformer tab. You can change the nominal power to 30 MVA and change the nominal frequency to 50 Hz. And you can add the grid side voltage as 400 kilovolts. If you have the impedance data, then you can calculate the R and X values. You can change these values. I didn't change now. Just I am changing the grid side voltage, nominal frequency, and nominal power of the path transformer. After that, just you can go to the inverter transformer. And you can change the nominal power to 30 MVA and nominal frequency to 50 Hz. And click OK. After that, just you can double click on this power meter and change the frequency from 60 Hz to 50 Hz. And click OK. Just you can double click on this power meter, change the frequency to 60 Hz to 50 Hz and click OK. If you want to see the sub-circuit of this wind park, just you can click on this wind park, right click. There is a push into option is available. To see the sub-circuit of that wind park, just you can click on that wind park, right click. There is a push into option is available. Just you can click on this push into. You can able to see the complete sub-circuit and complete components of the DFIG wind park. You can able to see here. What are the control DFIG controls? Again, it is a sub-circuit. You can double click on it. You can able to see the each and every component sub-circuit directly. Like this. Just you can double click and you can able to see the what are the protections and what are the controls available. All the things you can see. For that, just you can click on that and right click push into. Just click on the wind turbine, right click. You can click on this push into. Then you can able to see the sub-circuit in the wind park model. So this we are created as a mask and we can enter the parameters here. After that, just you can click OK. Now I can correct the load for this bus. For that, just you can go to the load models. In the library, just you can go to the load models. Now I'm connecting the load at this bus. Just you can you can go to the load models in the library. Take the PQ load with load flow. You can click on this and drag to here. Now you can connect this load to this bus. Now I'm connecting the load at this bus. For this load, just you can go to the load models library. From there, I'm taking the PQ load with load flow. You can drag and drop that one and you can connect to this bus. Double click on this load flow, load model. Here you can enter the nominal voltage as 400 kilovolts. In this bus, where enter the single phase data, it is automatically calculated the 3-phase data. So we need to enter the single phase data here for the active power and reactive powers. So the nominal voltage I entered as a 400 kilovolts RMS line to line, and change this active power to 5 megawatts and reactive power to 2 MVAR, and change the frequency to 50 Hz. Just you can double click on that load one, change the nominal voltage to 400 kilovolts RMS line to line, and you can change the active power to 5 megawatt and reactive power to 2 MVAR, and click OK. Here we are entering the 5 megawatt and 2 MVAR, but here you can able to see the three-phase data as 15 megawatt and 6 MVAR. So it is automatically calculated and update the load values here. So after connecting this load, first I can able to run this model from load flow analysis. For load flow analysis, in EMTP, we have a load flow bus is available. Just you can go to the sources library. You can able to see the load flow bus. Here I am running the simulation start from the load flow analysis. So further, in EMTP, we have a load flow bus is available from the sources library. Just you can drag and drop this load flow bus to sending side of the transmission line. Like this, you can connect this load flow bus. Just double click on this load flow and change the control voltage to 400 kilovolts and 50 Hz. Here the bus type as slack bus, PQ bus or PV bus. Okay. Similarly, in VWZ1, you can select the load flow bus as slack bus LF1. Similarly, you can go to the voltage source, double click on the voltage source, and you can drag that as slack bus LF1 and click OK. Like this, we can connect the slack bus here and we can run the simulation in load flow. Then you can go to the simulate tab, simulation options, and click on the load flow solution. Here there is a find load flow solution is available. Just you can click on that, enable the find load flow solution and click OK. So you can run the simulation now. Just you can connect the load flow bus available in the sources library. You connect it to here and change the control voltage to 400 kilovolts and 50 Hz. And you can give the reference as a VWZ1 and click OK. After that, you can go to the simulate tab, simulation options. Just enable the find load flow solution and click OK. After run the simulation, the load flow here for me, the load flow solution is completed here with 2 number of iterations. Like this, you can run the load flow simulation. If you want to see the voltages at the buses and power flow through the transmission line and switches in the load flow solution, further, you require the one more tab here. Just you can go to the options tab, options library. In the parts by library, there is a options library is available. Just you can go to the options tab. You can drag and you can see view steady state option. So you can drag that view steady state option into GUI to see the output responses under load flow condition, load flow or steady state condition. So further, just you can go to the options library. There is a view steady state tab is available. Just you can drag and drop that view steady state tab into GUI. Double click on this view steady state tab. I am enabling under load flow solution here and change the frequency to 50 Hz. I can provide the power base as 1 MVA, that is 1 e power 6. Just double click on this view steady state tab. You can change the solution frequency to 50 Hz and enable the load flow solution and change the power base to 1E6, 1 MVA and click OK. After that, for this bus and for the buses, I can able to see the voltages at the buses. For that, just you can click on that bus, right click. There is a signal parameters is available. Just you can click on that signal parameters. For that, you can select the positive sequence voltage you required or phase voltages. What voltages you require, then you can enable that. Here I am enabling the positive sequence voltage V1. And I can enter the nominal voltage in per unit base as a 400 kilovolts. I can enter the nominal voltage as 400 kilovolts and click OK. Similarly for this bus also, just you can click on this bus and right click, go to the signal parameters tab. You can enter the nominal voltage as 400 kilovolts and enable the positive sequence voltage and click OK. Now, if you want to see the voltages, per unit voltages on these buses, then just you can go to the design tab. Go to the design tab, click on the show data or refresh. Just you can go to the design tab, click on this show data, refresh. So like this, we can able to add the bus voltages directly into the EMTP GUI. Or again, if you want, you can run the simulation also, these will be displayed. If you want to see the power flow, then you can click on this switch, right click, go to the steady state view, and enable the active power P key and reactive power Q key and click OK. If you want to enable the power flow for the switches, just you can click on that switch, right click, go to the steady state view. You can enable the power P key and Q key. If you want to add the current also, then you can add the current IK. After that, just you can click OK. Then you can go to the design tab and show data. Here you can able to see the power flow. Like this, you can enable the power flows and voltages at the buses and at the switches in the EMTP GUI directly in the load flow solution and steady state solution. Now we will go with the transient state analysis. Now we can create a fault. So further creating a fault, just you can go to the switches library. There is a fault available. Just you can double click on that fault and just drag and drop that fault into GUI and connect it to this bus. I am creating a fault on this bus. Just you can double click on that fault. Change the fault resistance to 0, and I am creating a fault for single phase to ground fault. And I am closing the fault at 1 second and clearing the fault at 1.2 seconds. I am creating a fault. For that, just you can go to the switches library and take the fault, drag and drop that fault, and you can connect this to bus 1. Double click on that fault, and you can create a fault at 1 second and clear the fault at 1.2 seconds. You can create a fault at 1 second and clear the fault at 1.2 seconds and click OK. Now just go to the Simulate tab, go to the simulation options. You can disable this Find Load Flow solution and enable the Start Steady State solution from Load Flow solution. Just you can go to the Simulate tab, simulation options. You can disable the Find Load Flow solution and enable the Start Steady State solution from Load Flow solution. And you can change the simulation time to 3 seconds. 3 seconds. Maximum simulation time to 3 seconds and main time step to 10 microseconds. Or you can increase the main time step to 30 microseconds also. Just you can go to the Simulate tab, simulation options. Just you can disable the Find Load Flow solution and you can enable the Start Steady State solution from Load Flow solution. Change the simulation time step T maximum to 3 seconds and main time step delta T to 30 microseconds and click OK. Just click OK. After that, you can run the simulation. It takes some time to start the simulation because in the WindPark we have a more number of components related to protection and control components. All these things, because of that, it takes some time. Here the simulation is started. After that, just you can click on the View Scopes with Scope View. Just you can click on the View Scopes with Scope View. Here I have added only the power meter here, PQ. So here in Scope View, I have only the power parameters PQM1, P control and Q control here. After clicking on the View Scopes with Scope View in Simulate tab, just you can check the data sources with your file name or not. You can check the data source as your file name wind turbine. Now you can go to the signal type as a control signal. And you can click on this P and Q signals and you can run the simulation. Here you can able to see the P and Q of the wind turbine. Here After 400 milliseconds, there is some small disturbance is there because of the converters. So here I am creating the fault at 1 second and clearing the fault at 1.2 seconds. I'm creating a fault at this point and clearing the fault at 1.2 seconds. So after some time, the wind turbine reaches to the steady state. Here I am running the simulation up to 3 seconds. So like this, you can create a fault, any type of a fault, and you can create the, you can see the transient response of the wind turbine. If you want to see the voltage at the wind turbine wind park, just you can connect the voltage scope 1 pin from the meters library. Just you can connect the voltage scope 1 pin from the meters library. Just you can connect the voltage scope 1 pin from the meters library to this wind park. And you can run the simulation again. Just you can run the simulation again after connecting this voltage meter at this wind park. So after that, just you can go to the scope tab, scope view. Just you can click on the view scope, say scope view. In the signal window, just you can refresh the waveforms. After that, you can click on the signal type as a node voltage and increase the phase number to 2 and add the phase voltages, A, B, and C phase voltages. And you can select all the waveforms and superimpose. Like this, you can parallelly see the responses while simulation also. Just you can run like this. Here you can able to see the, one second. Here you can able to zoom the responses if you want. Just you can select the XY tab. Here I am zooming this part. At 1 second, I am creating a single phase to ground fault. So it is reached to 0, one of the phase to reaches to 0, and other things we see the voltage as equal. So like this, we are clear the fault at 1.52 seconds. And you can see the voltage response also. If you want to see the harmonics in this voltage response, just you can go to the signal window, advanced function editor. Just you can go to the signal window, advanced function editor, select the category as harmonic analysis and change the function name to harmonic. If you want to see the harmonic list from 1 to 10 or 1 to 50 or 1 to 25, you can add how many you want and you can change the fundamental frequency to 50. Here I am adding the signal one by one, node voltage, increase the page number and add function. Similarly, phase B, you can click on the add function. For phase C also you can click and add function and you can run. Sorry. Okay, just I'm increasing the harmonic number to 25. Just I can delete this. If you want to see the harmonics, then you can able to see the voltage harmonics, or if you want to perform the FFT analysis, or you can calculate the total harmonic distortion. All the things are available here. Just I can add the harmonic of one piece. After that, I can add the total harmonic distortion. So I can add the same piece in the same page and add function. Just you can run. Then you can go to the page 3. Here you can able to see the what is the PhD value of this zoom. Then you can zoom it in in y-axis. Here you can able to see the different harmonic values by zooming. If you want to see the values of this, just you can click on select that waveform, right click on this show data. Here I am entering up to 25 harmonics, so that here I'm able to see the 25th harmonic order values currents. Like this, you can voltage. Like this, you can see the voltage harmonics and PHD values by using EMTP scope view directly. Similarly,
Ma'am,
if
how
you
to
want
show?
to create.
Hello, ma'am.
Hello?
Ma'am, how to show the
Yes,
data?
sir.
Ma'am, how to show the data on the bus? The blue color data and from design.
Okay. Okay, sir. Just you can click on this bus. Right click. There is a signal parameters is available. Just you can click on that signal parameters. Here you can enter the nominal voltage as 400 kilovolts and enable the positive sequence voltage and click OK.
Okay.
After that, just you can go to the design tab and click on the show data. Or you can again run the load flow analysis. Just for that, you can go to the simulator, simulation options. You can enable the load flow solution, click OK,
Okay.
and run the simulation. Then you can able to see the bus voltages directly in the load flow solution and steady state solution. Similarly, for the power flow also, just you can click on that switch,
Okay.
right click.
Okay.
There is a steady state view is available in the right click option. There is a steady state view is there. Just you can click on that steady state view and enable the powers or current. If you want, you can enable those also, PK and QK and IK if you want to add the current also. Then click OK.
Okay, ma'am.
Like this, you can generate and you can develop the model, and you can see the transient stability response of the wind turbine also.
Okay, ma'am. Thank you. Thank you, ma'am. Thank you.
Okay, sir. If you have the harmonic spectrum, then you can enter those harmonic spectrum into the harmonic current source of the harmonic tab of this DFIG wind park. Just you can use this harmonic model for both steady state and time domain simulation. Then only this harmonic model is used at the time of simulation in both the steady state and time domain simulations. If you want to add it, this harmonic spectrum as an input. Like this,
Hello,
we can
Monica?
create. Yeah, hello, sir.
Yeah, we have only remaining 15 minutes. Okay, so we have
Yeah,
to
it's
finish.
almost completed, sir.
Yes, sir, because the participants will go for the lunch and then back join at 2 p.m.
Yeah. In EMTP, just you can go to the file tab. There is a help and support option is available. There is a help documentations are available for the tutorials and reference. There is a quick overview of UMTP. Then you can see directly how you can develop the model. How you can connect the voltage meters and signals. Those things you can able to see from here. And we have a lot of examples available in EMTP software related to renewables, protection, GRV analysis, synchronous and asynchronous machine. All these things you can able to see in the examples. Yes, if you have any doubts, you can ask.
Madam, excuse me. No?
Yeah, hello.
Madam, during the fault condition, I want to measure the impedance between the transmission lines. How can I do that? Hello? Are you getting my question, madam?
Yeah, hello, sir. Tell me.
I want to measure the transmission line impedance during the fault period. How can I, madam?
During the fault period,
for that you can measure the fault current and voltages. From that you can calculate the impedance of the transmission.
Is there any meter something option in there here in EMTP, sir?
We have meters to calculate your voltages and currents using meters library, current and voltage meters, and control library. You can use the functions. Okay, control library and phase library. So you can convert the magnitude and angle and do the processing.
Okay, sir. Thank you, sir.
Yeah, thank you.
Hello.
Monica, continue the session. Yes, yeah.
Hello. Yes, sir.
Hello.
Yeah, hello, sir. Tell me.
Ma'am, in my result, the fault is creating before, before 1, ma'am. The fault is clearing at 1.2.
I didn't understand, sir. Once again, can you please tell?
Ma'am, that the waveforms were different from what you are displaying and what I am getting.
Okay, sir. I think okay, sir. Just you can double click on the fault. You can check the closing time and clearing time of that fault. Here I am closing the fault at 1 second, and that means I am creating a fault at 1 second and clearing the fault at 1.
Closing time is 1 and then clearing time is 1.2 I had given seconds.
Okay.
And the switching time also the same thing. Your closing time is T close is a -1, and then open is that is a close
Never
in a
open.
steady state and then never open. Same I had given in seconds.
Okay.
But if you don't mind, could you? Running is okay, ma'am. Then the result can you show me once again, if you possible, if it's possible.
Yes, here you are added the in the simulation options. Here you are added for the 3 seconds. I think before it is in milliseconds, sir. You can check that one. It is in milliseconds or seconds. After that, you can run the simulation.
Is that in design, ma'am?
Just in the simulate tab, in the simulation options.
Yeah, 30.
You can enter the maximum 30 microseconds
30
and 3 seconds.
Yes,
3
ma'am.
seconds.
Given.
Yeah, because of that
30
you did.
3 seconds.
Okay, after that,
Same
just you
one.
can run the simulation.
Okay.
Just you can run the simulation.
Yeah, running.
And you can able to see the response like this.
1 second, ma'am. It is running. Yeah, over, ma'am. Then I went. click on the view scope and
Yes, sir. Okay.
then I got I mean control signal means of P and Q are given.
Yes, sir.
First I will remove all those.
Okay. Just you can run again.
Remove all. It is random. Here we are having a PQM1
Yes,
bar P and
PQM1.
PQM1 bar Q.
Yes, sir.
Yeah, I clicked on that
Just
one.
you can
It
add.
is added.
Yeah,
Signal we are having.
Okay.
I run again instead.
Yes, you can run the scope view.
But you are in the zoomed mode or
No, sir, not in the zoomed mode. It is in the normal mode only.
normal mode only? But I am getting different waveform. Here that PPM1, that is nothing but upper waveform is at I mean minus 2.5 to 0.5 only I am getting.
Okay. Okay, sir. I think
Negatively we are getting.
okay. So I think here we are connecting the power meter direction. You can see if it may be in reverse direction. You can check that one because of that.
How to change them? That the direction.
Yes, sir.
How to change them?
Just you can click on that and you can right click, flip horizontal, and flip horizontal, and you can connect again.
I right click them. That horizontal option not came, I think.
Flip horizontal is there, sir. Just you can check, right click. Under right click you have more options are there. In that you can click on that flip horizontal.
Flip horizontal. Okay.
Yes, sir. And then you can connect.
Okay.
If you want to see the component is connected or not in the system, just you can, after the connecting all the components, just you can click on the control button and double click on any one of the component. So it is like this. It should be like this. You can get like this.
One more
on
thing,
green color forms.
wind forms you are connected now, ma'am.
Which one, sir?
Hello.
Yeah, hello,
Wind
sir.
forms that how you change that direction, ma'am, that pin direction.
Similarly for
control
the wind
R
also, just you can. Yes, sir.
Control R
Similarly, you can.
Okay.
Yeah, you can use that controller or flip horizontal.
Okay. Thank you.
Okay, sir.
Last 5 minutes. Please let us know if you have any clarifications. I think only
Hello?
can go to presentation. Our contacts. Yeah.
Ma'am, session completed?
Yes, sir. Session is completed. If you have any doubts, you can ask.
Madam, I have one request, ma'am.
Yes, sir.
The session was really nice.
Thank you, sir. Yeah, hello, sir.
Morning I given there was some problem, ma'am, regarding installation of my software.
Okay.
I was just now I was installed my software, ma'am, in my laptop. What I want to say is, what I want to request is, after the session, you take a new example and then I'm able to learn something about software. Hello?
Yeah, hello, sir.
Hello?
After the session, yeah, hello, sir. We will provide the documentation, sir.
Afternoon session, you take a new example. Those who are not able to install the software in morning session, I was installed now. I can practice the software.
Yeah, that is good, sir. But the thing, so in the 2 o'clock next session will start. If you look continuously on this, the next session you will miss it. Okay. So next session with the JMate software, especially for modeling of the transformers, special motors and finite element analysis. Lot of features are available. You can have that session at 2 o'clock. Okay.
Yes,
So
sir.
later you can for the EMTP learning, the basic videos are available in YouTube. Okay. So how to start and create a simple circuit and run the simulation, plot the responses. So these tutorials are available in YouTube. Monica, just you go to the EMTP website.
Yes, sir.
Okay, well.
YouTube. Just you go to YouTube, type EMTP. And then you can find this EMTP channel, very first one. Very first one is your EMTP channel. And all the video tutorials are available in
Okay, sir.
Hello.
Okay, sir. Thank you very much, sir.
Okay, sir.
Hello.
Thank you, sir.
Yeah, hello, ma'am.
Ma'am, is this software is easily available, or we have to purchase this software, or it is freely available?
Madam, it is purchased from our side, madam. Through college, you need to purchase the software.
Okay.
This is licensed. Okay.
License
So
software,
Monica,
na?
you can share. Yeah, we can share our contact details so the people will able to receive
Yes,
the.
sir. Yes, sir. You share some contact detail and some information regarding you so that we can purchase it.
Yes. Go to the presentation and show our email ID and contact number.
Yes, yes, sir.
No, I think I'm not added that one in the PPT, sir.
Just you can type it, yeah.
Yeah.
Yeah, you can type my contact number.
Yeah, yes, sir.
Yeah. Can give me the.
Yes, I am adding it.
And also somebody.
Yeah.
Hello. Yes.
Yeah, hello, ma'am.
Hello. Yes, yeah, please talk, madam.
Sir, could you please tell us what is the next session is all about?
Okay, madam, yeah. So next session at 2 p.m.
Okay.
About GMX software, especially for electromagnetics. So what is the purpose of the electromagnetic design and how GMX software helps to design the electromagnetics and how the flux will flow, flux linkages and heat generated torque. So how to optimize the electric torque. So all these functionalities will be explored by our team members.
Oh, okay, sir. Thank you very much.
Yeah.
Hello.
So the next
Hello, sir.
session, yes, yeah.
Hello, sir. My scope view is not opening.
Okay. I think there is some firewall protection is enabled in your computer. Okay. So which will stops to enable the scope view. So you go to
No,
the
actually, it
EMTP
was
installation. Yeah, you go
no,
to the
actually,
EMTP installation folder and go to scope view folder. There is a scope view you can directly open and input the file.
okay. Okay, sir. Okay, thank you.
And you can also write email ID, Monica.
Okay. So it is VP.Pupati.
And also. Yes, sir. Yeah. So we also have a detailed training program, 3 days training program of EMTP available uh, from 28th to 31st May. Okay. So please, if you are interested, please contact us. So the registration is almost in close. So could you please confirm your interest to learn about the EMTP software?
So what would be the charges for that course, which is would be going from 28th to 31st?
For students, it is 6,000 plus GST, sir. For working
Okay.
professionals, it is 10,000 plus GST for 3 days training program. For those 3 days also, we can provide the license details and software with you.
Okay. Okay, no worries.
And
And about the
after this workshop,
huh.
the JMEC team will come 2 p.m. Okay, so they will start the session at 2 p.m. and you can join the session, and so you can have all the discussion about the JMEC.
No, I was just asking. How should we download that software for that session, or we won't need to be downloading that? That
No,
was.
no, there is no software is provided because it is only for 2 hours. It is very complicated to install and hands-on session.
Okay. Okay. Sure. Okay. Thank you, sir.
Yeah. I think, Monica, the clarification is over. I think participants will please take your lunch and join the session at 2 o'clock.
Okay, sir.
Okay, yeah.
Thank you, everyone.
Thank you.
Okay, sir. Thank you.
Dear participants, please take your click same link so you will join the session at 2 o'clock.
So should we disconnect now or what?
So you can disconnect and again click same link, you will join the session.
Okay. Thank you, sir.
Thank you.
muted. Hello, good afternoon, everyone. Welcome to a new session on electromagnetic transient workshop hosted by New Horizon College, Bangalore. I hope you had a wonderful session in the forenoon with the EMTP software. I'm your host for the day. My name is Adib, and I'll be taking you over with the JMAG tool, which is an electromechanical design tool used for FE analysis. I'll be presenting you from 2 to 3, and from 3 to 4, one of my colleagues will be handling another session on the efficiency map analysis using JMAG. So let us start without further ado. Okay, so if you see, JMAG is a simulation platform that was developed by the JSOL Corporation in Japan in the year 1983, and it is a comprehensive design suite which is used for FE analysis, that is the finite element analysis, and it can be used for the design of a electromechanical device, the validation of the device, the optimization with respect to the design, as well as you can also do the coupled electromagnetic or the thermal or the structural analysis using this JMAG FEA software. So if you see our market, so we are mostly focusing on the automotive aspects, like you can see with the current interest towards electrification or the electric vehicle scenario. There has been a huge demand in this side of FE analysis of electrical motors and drives. So JMAG has the potential to access all your problems regarding to this electrification theme and design of electromechanical devices. So apart from the automotive components, so you have another set of examples, like we deal with the electrical machinery industries or heavy industries, as well as research institutes like academic collaborations. We do have few academic collaborations and we do projects associated with them. And the type of machines that we target using JMAG are mostly motors, alternators, transformers, switch gears, solenoids, reactors, etc. Okay. So moving on to the next slide, like I told you, JMAG is a finite element simulation software which can solve complex problems with respect to the motor design aspects or transformer design. Likewise, you can split your model down into a number of mesh elements so that you can simplify your problem. So each mesh element will be solved using different differential equation forms. So that is inbuilt within the software, and it will help you in identifying or critically analyzing the design that you have done through simulation. So we have done many number of technical consultancy work around the globe, as well as in India, with respect to the industry as well as the academia. So we belong to our parental company known as PWSIM, and as part of that, we operate in India in the name of PWSIM. So we have branches in Chennai as well as Bangalore. So today I'll be covering a few topics, like the main three tools that are used in JMAG. That is, one is the JMAG Express, which supports the motor design. Then you have the JMAG Designer, which is used for the detailed FE analysis, and followed by the JMAG RT. So it helps in real-time control simulations. Like you can integrate JMAG tool with some other softwares like MATLAB or DSpace or whatever, and you can do a complete platform based drive simulation. Or you can also use PSIM. So I think you have the PSIM session scheduled for tomorrow. And coming to JMAG, so this is the crux of JMAG. Like I told you, I'll show you here, like this is the basic tool that is used in JMAG to design a model. So even if you don't have much idea about a machine, you can use this option of JMAG Express. So if you only have, say, for example, you have only a few details regarding to the motor, like you only know the power output, or you know only the say what type of size your motor should have, or something like that, and the type of the motor, you can directly feed it in JMAG Express, and you will get an approximate model to work with. So that is with respect to JMAG Express. And if you can see, you can either create your own model based on the templates that are already available within the JMAG Express, or there is also a provision of importing some of your CAD files. So even if you have the CAD details, you can directly import it to JMag Express and work on that. And similar to Express, I told you there is a designer option, JMag Designer. So it is used for the finite element analysis and for doing a detailed simulation of your motor model. So if you see, these are some of the CADs that we support. Like you can link it with SolidWorks, CATIA, Creo, Pro Engineer, NX, etc. And if you see, I told you about JMag RT, where we practice real-time simulation. So you can use the JMag tool to integrate it with the following tools like MATLAB, PSIM, LabVIEW, GT Suite, DSpace. So many of the options are available for you to do the SIL or HIL configuration. And also, likewise, if you want to do some other simulations which are not performed by JMag, you can simulate using the partner products. Like, for example, you have some NASA and Abacus, MPCCI, Speed, Staff CCM Plus, etc. So that you can do a detailed mechanical analysis or some cooling or fluid analysis with respect to these partner products. And we also support some of the third-party softwares like Mode Frontier, Nastran, Actron, AccuSolve, etc. So here, if you see, you have to supply a model to the tool, and you have to set up the pre-post, or you have to do the initial settings of your model. You can do the FE analysis, and then you can do a post optimization on the same subject. And also there is an option for scripting used within JMag. So you can script your model using either VB script or Python. Both are supported. And coming to the cloud-based support system, we also support a few cloud-based systems like the IBM Fujitsu or the Rescale platform. So you can save your models and you can analyze it using this functionality as well. So similarly, like Express, this is about Designer. So I'll get to that later. So if you see, like I told you, Express is the most basic tool that is there in JMag. So the Express needs a few inputs from your side or the user side, and it will do the analysis and give you the following outputs, like the basic requirements. I told you, like JMag can also operate on something like, if you don't know the machine design, you input a few details, it will give an approximate data to work with. So if you see, these are the approximate data like I was talking about. If you have your complete design details, then well and good. You can directly input it, like you can define the geometry design or the geometric specifications, like the dimension, the material width, the core back width, or so many other parameters corresponding to the different motor models that are available within the JMag. Then you can assign the material data. So JMag has a very good library of material from different vendors. So you can directly input the material of your choice, and there is also provision of creating your own material. Suppose you find that there is some material that is not available within JMag, you can go and add your own material here. And after that, you can use the winding data analysis. So here you can input the winding details like the number of turns, the insulation factor that you are using, the stack, the slot fill factors that you are using. Those things can be done in the winding data area. And also then you have the drive data. And also then you have the drive data where you can fill in your drive requirement. Like JMag Express has inbuilt drive for your motor model. So it will be exclusively based on the motor model that you select. Suppose you want to make some changes in your drive details, you have to export your model to the JMag Designer, wherein you can add your own circuit of your choice. Okay. And going back to the output side, so once you have finished initializing your motor and inputting all these parameters, you can then press the evaluate button, and then you will get the outputs pertaining to these. So these are some of the outputs that we focus on in JMag Express, like the torque, the speed, the efficiency, power factor, and as well as the design sheet. So all this will give you an idea of how your motor is going to perform. And once you are satisfied with your basic model in Express, you can directly export it to JMag Designer, where you can do the finite element analysis. Now that unmuted. So now if you see, these are some of the motor types that can be analyzed using JMAG. So there are some few more. So these are some of the basic types, like you have the IPM, in interior permanent magnet, you have the surface permanent magnet, the induction motor, the brushed motor, switch reluctance motor, universal motor, as well as synchronous machines. So for all these, you have inbuilt templates for in JMAG Express. And inbuilt templates, you have different stator rotor combinations. So you can select the stator rotor combination of your choice. And like I told you, there is also a provision of editing that stator rotor combination as well as using your own models or CAD models in JMAG. Now, these are the two options. Like I told you, you can either use your DXF file or you can use the standard templates that is available within JMAG. So this is how you create a stator and rotor geometry using JMAG. So suppose you have the DXF file you have created in any other software, you can import it here. And there is also a geometry CAD editor within JMAG where you can draw your stator rotor geometry, and you can combine that and you can export it to Designer or Express. So that provision is also there within JMAG. So suppose you see, like I told you, for this example, you see there are more than 10 design stampings of rotor and stator for this particular motor type that we have selected. Like this, for each motor model, there are different options that is available for you. Like for stator, you will have some 10 or 15 combinations. For rotor also, you can have 10 or 15 combinations, and you can edit your template. So whatever template you have selected, you can edit it here, or else you can create a new template from your JCF or DXF file. Okay. And this is what I was talking about, like the inputs pertaining to JMAG Express. So first you have to input the geometry details, like the major ones, like the outer diameter of stator, air gap, stack heights, and all the other parameters will be with respect to the motor type you select. So for this, I think this is a permanent magnet motor. So you have to specify the magnet thickness, the magnet angle, the magnet corner angle, the number of slots, all these things. And so once you are done with the dimensions or the geometry details, you can then go to the material data section. So like I told you, you have to assign the material. What material you are going to use for your stator, your rotor, the coil. So all these things you have to specify. And if you go to down to category, you can find different vendors having their own types of steel. And so you can use it directly using the material data option, and the product you can list it from here. So the products like S45C, or there are different options, JNE or JFE. What type of steel you are going to use, the magnetic flux density will be displayed here, and based on your requirement, you can select your material. And there is also an option of adding your custom steel material within JMAG. Now going to the winding data option, likewise I told you, here you can input or set your winding details, whether it is a lap winding or wave winding, or what is the coil resistance. So you can mention the coil resistance here. You can input the slot fill factor, and also within the coil resistance, there are different options. Like you can select like turns per wire size, turn per slot fill factor. So there are different options. So whatever option you are inputting here, based on that, the JMAG will automatically calculate the number of turns or the coil resistance for you. Okay. And going to the drive side, like I told you, this is an inbuilt drive that is available within JMAG. So for a particular motor type, there will be a particular drive, and you have to set your input details for the drive. In this case, you have to mention the DC voltage, the rated current, the brush width, the lead angle, etc. And suppose you want to edit this drive, you have to take this model to JMAG Designer, where you can edit your circuit. Now, once you have given the inputs and press the evaluate button, you will get your output results within a click of a second. Like these are the output results that we focus on in JMAG Express. Like what is the current, maximum current, how much it is going to, at what speed, what is the copper loss associated, how much power you are obtaining from your model, what is the efficiency curve you are getting, what is the iron loss. So these are some of the basic graphs that we look forward to in JMag Express. Apart from this graph, there are many more graphs that are available within JMag. So you just have to study a little more, and you can get the graphs according to your requirements. So what graph you are looking at, you will be able to get it in JMag Express. Now then, this is another important feature I was telling about, like about the design sheet. So once you have run your simulation, you will get a sheet of this type. So this is the input design sheet or the output design sheet that you have obtained when you have created your design and when you have run the model. So in this, you can see that whatever details you have given, all the details are covered here. And apart from that, some of the output details are also obtained. Like for example, if you see on this side, you can see a mass property table. So here you can assess whether the model you have done can be inputted or can be fixed into a particular uh, particular instrument of your choice, like the weight pertaining to the motor. This is going up to say 3.7 kilogram. So every time, so for whatever design you do, the initial thing that you do in machine design, you have to set up the weight as well as the output density that you are going to obtain from the motor. So this weight becomes an important factor for any machine design when you are going to do a new machine design. And these factors will help you in understanding how much amount of weight is being gone to the stator core for the coil, how much coil mass is required. And this will help you also in preparation of a bill of material. So you can assess how much cost will be parameters can be optimized. So it can be parametrically optimized, and this is one of the important functions of JMag Express. So suppose if you want to vary this outer diameter in between, say, I want to see how the motor performs between 100 and 120 mm diameter. So you can just press this and you can input your value and you can set the number of divisions and you can run your analysis. And for this model, it will show you how much is the values of torque, or like I told you, how much is the torque change, how much is the current change, how much is the power efficiency change with respect to your optimization module. So this yellow color things becomes a huge factor for importance. Like you can get an initial idea about your model, and you can get confidence while you are doing this parametric optimization. So this is another important thing about JMag Express. So first one is the input. So you have to input the details like the geometrical dimensions, then you have to go for the material section, then you have to input your winding details, followed by the drive details. So once you are done with that, you have to go for the evaluation. And once you do the evaluation, you will get the graphs. So from the graphs, you can understand whether your motor model is fine or working with respect to the design you have done. And apart from that, you will get a design sheet where you can get details like the mass property, you can get the details about the winding as well as the machine parameters. And here with this yellow colored tabs or parameters, you can optimize your model and you can come up with a better model using the JMag Express tool itself. Now, this is about JMag Express. So this is the basic template in JMag. Now going to the JMag Designer. JMag Designer is actually the finite element analysis platform which we have in JMag. So whatever model you have created in Express, you can either export it directly into the JMag Designer, or you can input your own DXF file directly into Designer. So we are giving both the provisions. So like you can see in the input side here, the JMag Express file can be directly inputted, or else you can do your own 2D, 3D CAD modeling, and you can input here in the JMag Designer. And in the Designer, like I have told in Express, you have to, suppose you have done using JMag Express, all this material condition, the coil conditions, the power supply, the boundary condition, etc. will be automatically taken care by the model because you are directly exporting the model from Express. Okay, but suppose if you are doing it via the 2D, 3D CAD modeling, you have to assign all this on your own. Like in Express, you have a material modeling option. In JMAG Designer, you have the FEM coil and circuit modeling option, the power supply option, and the boundary conditions, and as well as meshing. So now, when you are done with the input side of things in JMAG Designer, you have a provision to select what type of magnetic analysis you are going to do on your motor. Likewise, you have the provision to do the static analysis. You have the provision of doing the transient analysis, the frequency analysis, as well as axisymmetric analysis. And like I told you, there are some of the outputs, like we have seen some of the outputs that we look forward to in Express. Likewise, in Designer, these are some of the parameters or outputs that we are interested in. So you can see your magnetic flux distribution plot, you can see the contour plot, you can see the vector plot, you can see flux lines flowing into your motor, how the flux distribution happens, and you can see the electrical power, the torque graph, the current power factor, efficiency, as well as you can do other calculations, like you can assess the THD of the your drive design, you can do the FFT analysis, you can assess the eddy currents in the motor, as well as some in the cases of some special machines like the brushless motor or the switch reluctance motor, sometimes you want to see the torque ripple and all other things. So these things can also be done using the JMAG Designer tool. So this is about the input and output side of JMAG Designer. Now, if I go further, this is how like I told you, you can import your CAD model from other softwares like SolidWorks, for example. Likewise, JMAG also gives you provisions to do your CAD modeling within JMAG. So there is a geometry CAD link in JMAG where you can draw your own CAD models. So this is how they are doing the CAD model. So for all this, for doing your CAD modeling and doing the circuit conditions or the motor dimension conditions, as well as the analysis conditions, JMAG has exclusive inbuilt self-learning system. So whatever motor model or whatever electromagnetic device you are going to make, there are input models and self-learning available within JMAG. So which will guide you from scratch, like how to create your stator from scratch. From the initial step till the final step, it will give you a complete overview of the design. So this is one of the important features with respect to JMAG. And you can draw a 2D model as well as a 3D model directly using the CAD link. Now moving forward, like I told you, in Express, there is an inbuilt drive for all the different motor types. So if you, like I told you, if you had to change the drive parameters or the drive circuit in JMAG Express, it wouldn't be possible. So you have to export that model to the JMAG Designer window, and here you can create your own circuit models, different combinations of circuits you can try. And for now, if you can do the star delta transition, as well as creating the cage and entering shortcut circuit connection. So according to your choice, you can do your drive. So this is another important functionality in JMAG Designer. Now, like I told you, this is the core concept of FEA, or the finite element analysis. Likewise, you can see a number of mesh elements in the triangular form in different parts of the motor model. Like you can see it here in the coils, in the stator tooth, in the core back, as well as here within the near the air gap. So if you see, the number of mesh elements is more here near the air gap, because this is where the flux flows, and this is the point of interest in any magnetic analysis study. So you can see more number of mesh elements here within the air gap, and other where it will be almost uniform. And how it happens is that you can solve your model with respect to the different meshing techniques that is available within JMAG. So there are different meshing options like the slide mesh option, the semi-automatic, automatic option. You have the extruded mesh option, skin mesh option, layered mesh option. So there are different meshing options that is available within JMAG. So based upon your requirement and whatever type of analysis you are doing, you can select the mesh of your choice, and you can come up with good results using that. And JMAG has another feature, like the mesh elements and the mesh sizing are done in such a way that the time for the analysis is very short. So GPU or the processing unit within JMAG is very fast to solve your motor models of very huge number of size and mesh. Now, if you want to see, like I told you, the magnetic analysis results that we look forward to within JMAG. So this is the magnetic flux density contour plot. So you can see the details of the how your Tesla or the magnetic flux density is varying within the motor from a value say 0 to 2.4 Tesla. And you can see different column combinations with respect to that. Similarly, the magnetic flux lines, how the magnetic flux lines are flowing from the stator teeth to the next neighboring stator teeth to the rotor side or the rotor magnets within the rotor magnets. So all these things can be analyzed beautifully using JMAG window. And there are also provisions for analyzing the iron loss density distribution, where you can get the how much iron loss is happening within the motor. These are some of the few ones I'm talking about. There are many more types of analysis and results that you can see using the JMAG designer window. And if you come to the other graphs that you can obtain using the JMAG designer, you can see, you can assess the circuit current, how the circuit current is going within your motor model, and the torque, different torque with respect to the revolution speed. You can see for this example, suppose you can see the stalling torque or the starting torque, at what point the torque starts, and the breakdown or the pull out torque, at what point the motor is going out of this constant torque operation. So all these things can be analyzed beautifully with respect to JMAG tool. And this is like the iron loss density. You can see the joule loss, how much copper loss is happening within your motor model. All the details you can see, and where if suppose in some places hotspot or something is happening, whether the motor is getting heated up too much. So all these things you can analyze using the joule loss density distribution function. So this is the vector plot, how the vector lines are flowing within the motor. And suppose you can see some hotspots being created here. So these things you can analyze. Also the flux variation near the air gap. So this fixing the air gap flux density is one of the important parameters when you do any machine design. So this thing can also be analyzed using this JMAG tool. So with respect to the permanent magnet motors, you can see the LD-LQ curve, the inductance graph with respect to current phase angle, the torque versus the current phase angle, as well as the electromagnetic force angles. And adding to that, so there are so many types of analysis that you can do and so many types of results that you can get out of designer. Like for example, the Coging torque in permanent magnet motor is one of the most interesting studies that is happening today. So this thing can be easily done using the JMAG tool. And adding to that, you have the eddy current density distribution, the nodal force distribution, whether some when you apply some force, what is happening to the surface. So these studies can be done in JMAG. And from the iron loss and hysteresis loss, how you are calculating the eddy current loss. Now moving forward, I have told you about JMAG Express, the basic template, the JMAG designer, the FEA model. Now I come to another important study topic, like the JMAG designer thermal module. So you can do the thermal as well as the structural analysis within JMAG. And if you see here, previously we had discussed about only 2D models. So suppose if you want to do the thermal module, you have to go for the 3D option. So when you select the 3D module, you can do the thermal study. And two types of study are possible within JMAG. One is the steady state analysis. The second one is the transient state analysis. So steady state analysis will give you the motor after it has run for some period of time, and transient state analysis will give you the temperature distribution when the motor is running. So these two things can be done using the thermal module. And if you see, like we have seen in designer, there are some of the inputs that has to be given into the motor model. In JMAG designer thermal module, you have to give additional things, like you have to draw a thermal circuit. The thermal circuit will contain how the air is getting flown from the rotor to the stator, out to the casing, and out from the casing. So all these things you have to draw in the form of a thermal circuit. You have to assign the heat transfer boundary condition as well as the material properties. So previously you had only to do the material integration in you have to give the thermal property of that particular material. So obviously that will be available with any other manufacturer who is giving their product. So you can directly contact them and get these details. And another input to the thermal module will be the copper loss, the stator and rotor core loss, the eddy current loss, the end ring and cage loss, as well as the magnet loss that is happening within the motor. So initially you have to do the loss study, and this loss study you can couple with the thermal study. So this is how the thermal module works. And if I go further from the thermal study, if you do these types of analysis, you can get the following outputs. Like you can see the temperature, the hot spots that is happening within the motor design, the heat flux that is there, and as well as the heat flux density. So this is what I was talking about. So this is a thermal circuit that has been drawn for this particular motor type, and how you come with this thermal circuit, for example. So suppose if you see here how the heat transfer is occurring from the shaft, the rotor, to the air gap, to the stator, to the coil in the stator, to the cover, and outside of the cover to the heat. So you have to draw based on this a thermal circuit here. Like here you can mention how the rotor is handling the air present near it, how the stator core is handling the air as well as the coil to air, and in the same this way how this is connected to the casing or the cover of the motor. And you can input your heat transfer details or the ambient air condition details here. So once you are doing this, the JMAG will automatically take it as the thermal circuit for its operation of the thermal module. Now going to, this is another input I told you, like it is more important in the point of view of thermal module. So this is the heat transfer boundary condition. So whatever boundaries that you are considering for this thermal analysis, you have to select it. So whatever you have created there, the rotor core to air, the rotor core to the air gap. So there will be an air gap here. So how it is conducting the heat, the shaft to the air on both sides, the stator core to the gap. So this is the stator, and this how it conducts the heat from the air gap. The stator core to the air, as well as the entering to the air. So this condition is a very important condition in the thermal analysis. Now, like I told you, these are the two types of analysis that you can do. You can do either the steady state analysis. So after the motor has run for your particular analysis, how much is the temperature distribution? So now you can see like inside the stator, the temperature is rising up to say 125 degrees Celsius. So you can make a good assessment of what application you are doing, how much temperature rise is happening when I am doing this design for that particular application, and how whether my motor model will work in practical or not. So all these things. So you can see the minimum heat that is produced is 65 degrees Celsius and the maximum is 122 degrees Celsius. Likewise, this is the steady state analysis. You have the transient state analysis. So you can see the motor is being run for say 0 to 8,000 seconds. And if you see here, you can see the transient state, how the stator core temperature is increasing, how the coil temperature is increasing with respect to the speed, how the rotor core temperature is increasing, how the cage temperature is increasing. So this is a transient state analysis. So you can get a good idea about the transients, how it is working or not. Now, from the thermal analysis study, you will get a picture whether your motor will be functional when it is being put into the practical use. Suppose, for example, if you are using an electric vehicle application and you are designing a motor for that application, in India, if you see the temperature variations are huge. Suppose if you go to some parts of India, it will be very cold. In some parts, it will be very hot. Like for example, in Rajasthan, if you go, the temperature conditions will be very high. And if you haven't done a thermal analysis for your motor module, there are good chances that your motor will fail when you put it for testing. So These things have happened practically for different industries or manufacturers, and such analysis or such simulations is a must for applications like electrical vehicles. There might be applications where thermal analysis is not a requirement, like some applications which are doing some constant operations throughout, wherein the load applied to the motor will be not a full load, it will be a constant load, and there will be no accelerated loads happening when the motor is functioning. So for such type of application, thermal analysis is not a requirement, but for today's theme or the electrification theme on electric vehicles, thermal analysis is a very important aspect with respect to any electrical machine designer. Now, coming to from the thermal analysis, you have another type of analysis called the structural analysis within. So here you can analyze on the switch reluctance motor. You are switching the motor, you are switching it at a very high frequency. So whether or not the motor is going to last for a, maybe your motor is going to work for a period of say 5 months or 6 months, but whether it is going to function after that. So when you do switching at very high frequencies, there are many chances that the stator or the core can vibrate, the stator can change its pattern. So all these type of analysis is a must for some applications like the electric vehicle, like I told you previously. So with the structural module within JMAC Designer, you can assign the electromagnetic forces and the boundary conditions that you are going to input on your motor, and you can do these types of analysis, the static analysis, the eigen mode analysis, the frequency analysis, as well as the transient analysis, and you can obtain results like how much sound your motor is producing, how much acceleration or how much displacement it is producing, as well as the changes in the shape of the stator or the rotor, how much stress is being performed on the motor because of your actions. So if you see here, sorry, so if you see here, in this motor model, we have applied a rigid body condition at the bearing location, and electromagnetic force is applied on the stator core. So from this particular analysis, we have arrived at FFT analysis, where you can see how much is the amplitude of force that is being exerted on the motor model. So this is one aspect of the structural module that I was talking about. And suppose if you see how the electromagnetic forces affect your system, how the stresses are being calculated. So how much centrifugal force is being applied on the rotor magnet, you can see it here, and its value is seen here in Pascal. You can see how much force is being acting on, and like I told you, how the stator is getting deformed at a frequency of 3600 hertz. So these are things, some of the things that we don't look forward to while we are doing a machine design, but this is actually very important from the application point of view. It's not necessary that whatever switching frequency you are giving, the motor will work initially, but as the time progresses, the stator can change its shape, as well as from the noise point of view. If you see how much noise it is going to emit over a period of time. So in this case, you can see, say, from 0 decibel to 30 decibel. So what values of sound pressure is being obtained from your motor model. So these are some of the analysis results that you can obtain from the structural model of JMAC Designer. And also, I told you, like, now we have covered the Express, the Designer thermal module, the Designer structural module. Now you have the Designer RT module, where you do the real-time simulation. Like, you can link it with another drive software like the PWSIM software or DSpace software, and you can see the real-time results for your motor model. So you don't have to make a motor prototype initially. You can do the design and you can connect it into your drive simulator, and you can see the performance in real time. So here some of the inputs that you have to give in the RT are the mesh data or whatever the motor details you have made in Designer. You can import it here as the input model, and you have to specify the current amplitude, the current phase angle, as well as the winding data. And in RT, for example, in the case of permanent magnet model, you can do the LD-LQ model as well as the spatial harmonic model. And the outputs, you can see the efficiency map where your motor, in which particular operating point the motor is giving the maximum efficiency, the LD inductance map with respect to the LD and the LQ axis, the iron loss map, the back EMF, the flux linkage, all these things can be obtained in real time. Okay, so this is what I was telling about. You can do either the LD-LQ model as well as the spatial harmonic model with respect to the inductance, torque with current, and a phase angle dependency. So in the RT, like I told you, in this particular image, you can get the efficiency map. So with respect to torque, speed, and efficiency, how your efficiency map will look like, and at what operating point you can operate your motor so that it will last longer or it will give you the optimum performance. So whatever constraint you have put on your motor, you can analyze it using the efficiency map. And my colleague, Mr. Joseph, he will be explaining you how you can do the efficiency map analysis in the RT viewer. That is his topic. And I hope you will understand more regarding efficiency map in his lecture. And these are some of the curves, like I told you, the beta, IAM, and LD graph. So this is also helpful in analyzing whether the inductance or the direct axis inductance is sufficient for your particular model. And likewise, there are LQ maps, the iron loss map, and the back EMF map. So iron loss, you can understand how much iron loss is happening when you are performing this current versus speed operation at particular points, and you can select your operating point within this range. So wherever you are feeling that your application is suitable, you can fix that operating point and you can go forward. So this is one of the motor models that we have implemented in MATLAB. So this is the JMAG RT model that you can import in MATLAB, and you can run the control simulation here. So this is the MOSFET and this is the control pulses that we have developed, and you can see the output results either in MATLAB or in JMAG. So it does a step-by-step simulation. So JMAG will operate one step, MATLAB will operate another step. So you will get a step-by-step simulation result with respect to torque graph, the current graph, the speed graph, when you couple the JMAG with the MATLAB. So this is a basic idea about the JMAG tool, different types of tools that are there within JMAG, like the Express Designer, as well as the JMAG RT model. These are some of our Indian customers as well as global customers. There are many more, so I have put only a few. So what are actually the benefits when you go for a finite element analysis? So the first one is the quantum reduction in design and development time. Like I told you, when you are doing a design type, if you have not done a complete analysis on that motor design that you have performed, when you're manufacturing it, thinking that the design is perfect and you have done it perfectly, there are chances that your motor will fail or you will not get the expected results. So doing a finite element analysis for your motor model will be highly beneficial because the accuracy of the results obtained from the finite element analysis tool like JMAG and the real-time simulation is approximately like 95 to 100%. So there are chances that your motor model, if you have done a good design, you will get a proper working model or a proper working prototype with help of JMAG simulation tool. And you can reduce the number of trials and error process in your development. So optimization, the parametric optimization to achieve your particular machine performance can be done in detail. You have provisions to even do the topology optimization within JMAG. You can do the skewing, the multi-slice conditions. Many options are available within the designer tool that will help you in building a prototype with a robust design. So this is about the JMAG tool. Now I will go fast. I will go fast because the session is scheduled to be over at 3 o'clock. I will just show you the GUI of the JMAG Express tool as well as the designer tool. So first, going to the Express tool. So I will show you few things here. So this is the basic GUI of JMAG Express. So suppose I tell you like I want to open a new motor model. So these are the motor models that are available within the JMAG Express. These are the inbuilt templates. You have the interior permanent magnet, the surface permanent magnet, outer rotor combination for the both, induction motor, both single and three phase, the switch reluctance motor, brush motor, universal motor, synchronous machine, both externally excited as well as found field, as well as the clock pole alternator. Now, suppose I want to do an analysis on the brushless motor, interior permanent magnet motor. If I open this, you can see there are options like I told you. You can either build using the template that is available within the JMag Express tool, or you can go for importing the DXF file that you have prepared in some other CAD software like SolidWorks. So for time being, if I press the build new combination, so it will ask me what type of rotor or stator shape you want. So there will be some 10 to 15 rotor shapes and 10 to 15 stator shapes. So you can choose selected based upon your choice of application, what type of stator rotor combination you want. So this will be applicable for all the motor types. So for every motor type, there will be a number of combinations of stator as well as rotor types. So if I press OK, it's working on, so it will take a few seconds. So let it load. I think my system is overloaded. That is why it is taking some time. So I'll just show you something. I'll just show you. I will just show you some things like I told you, so this is about machine design webinar we had already conducted. So in doing a particular machine design, so you have to go through the requirement section. So you have to do a size examination chart, like I told you, how much weight you are going to set as a platform for your motor model, and the size. So this is the some of you, if you neglect when your machine design, is the size part. So initially you have to fix your size, only then you can work upon on a detailed analysis, and then you have to assess your performance, like what are output it is being shown in your motor model. You have to assess it whether it is good or not. Blindly believing on the results of tools wouldn't be good. So you have to assess the performance here. So from the requirements, you go to the size, go to the performance overview, and suppose you have to create the magnetic path geometry then. So for every motor model, it's very important to create the magnetic path geometry so that you can understand how much flux is being flowing through the stator tooth as well as the rotor part. So this is also one of the most important aspects in any machine design. So once you do all these 3-4 things, you will have an initial design proposal with you. So this initial design proposal, you can feed it into a tool like JMag Express, and you can assess the results properly. And from here, you can go for the detailed analysis using JMag Designer. Now, suppose, see, this is the motor model I have chosen. So this is an interior permanent magnet with this type of magnets, and this is the stator section. So I told you, like in JMag, there is a provision. So suppose if you know only the rated power of the motor 1 kilowatt, you can just press apply. It will get automatically applied here. And suppose if you have other parameters like maximum torque, rated revolution speed, maximum revolution speed for your motor model, you can just input the values here, press apply, you will get an approximate model to work with. So these are the parameters that are available in the requirement section for you to get an approximate model. So this is one condition. Suppose you have all your design details ready with you, then you go directly to the dimension section. So you can fix your dimensions here, the outer dia, the stator section, the rotor section, all these sections you can fix on your own. And like I told you, there is an option called modify. So here you can modify your template, and you can create some other provisions, like you can create some holes, you can change the pole shape. All these things are available. You can press the edit current template for that. Suppose you want to change the DXF file only for the stator, then you can press it here, and you can create the stator pole of your choice. So once the dimensions are ready, you directly go to the material section. I told you, material section, where you input the material for the different motor type parts. So this is the stator core type. This is for the coil, the rotor magnet, and the rotor core. So suppose if you want to fix a particular steel type, so if you go to the category, so like I told you, many number of vendors are available in Express. In designer, there are many more number of material classifications available. And suppose you fix the product. So suppose for this time, let us say 50A700, you can get the flux density curve here. Now suppose that if you don't have the manufacturer of your choice, there is a provision to add your particular motor model here. So if you go down, you have the custom steel option. You can press this. You can input the BH curve of your choice of your particular material. You can press OK, and that material will get displayed here. So these are some of the interesting things with respect to material configuration. Now you have fixed your dimensions of the motor. You have fixed the material. Now the time for fixing the winding. So if you see in the winding options, you can see the winding diagram here. The motor diagram is here above. The winding diagram, you can see that the slot diagram, everything you can see. So whatever changes you are going to make here, it will get reflected in the winding diagram as well as the slot diagram. So here, for suppose I told you, like, you can select the connection method, whether it is the star or delta connection for the IPM motor. And in the input item, you can see different combinations. Like suppose if you know only the phase resistance of your motor, you can directly input the phase value here, phase resistance value here. And based on that, all other parameters will be automatically taken care of. The wire diameter, the film thickness, number of strands, insulation thickness, etc. Now, there are also options like when you know all the other parameters and you don't know phase resistance, you input all other parameters, the phase resistance will be automatically calculated. So it is based upon your choice, whether you have all the details with you or you don't have the details. Based on that, you can select the input item. And here you can do the winding scheme. Like there are two options, whether you can do the automatic as well as the manual combination. In automatic, whatever layer and coil pitch you have given, automatically the winding happens. When you select the manual combination, there is provision for you to define from where the coil should start, from which slot it should start, and which slot it should end. So this is used for some special applications. So for the time being, let us go with the automatic. And the next section would be the drive. Like I told you, there is an option for you to design the drive details. So there are two options. You can do either the current source based operation or the voltage source based. So you can fix the line current here, for example, how much line current you are going to apply, and the revolution speed here. And in the x-axis, so this is with respect to the graph. So whatever x-axis parameter you are selecting, it will get displayed there. So now suppose we are going for the revolution speed. This is the overall thing about Express. So you have to input the dimensions, the materials, the winding, the drive details, etc. And if you see above, you can see an evaluation button. So if you press the evaluate button, you can see the torque graph, the efficiency curve, the power curve, the copper loss. So these things I have already mentioned in the PPT. And apart from that, you can see a design sheet here. A design sheet covers all the parameters that you have applied, all the dimensions you have given, the output parameters. You can see the LD, LQ value, the KT, KE value, the average teeth flux density. All these things you can see in the design sheet. And you can edit your graph here. There is an option called edit characteristics where you can edit the characteristics. And I told you one more thing, like all the yellow colored ones can be parameterized. So suppose the outer diameter now it is fixed at 54.65. Suppose I want to see the variation in the outer diameter from say 50 to 60. So I want to see the variation in the outer diameter in 50 to 60 in divisions of 5. So now if I evaluate the motor model, okay, the warning that was showing, because we have taken a random design, so the accuracy might be low. So that is the warning that was showing. So now you can see, so for different types of outer diameter, how your torque and efficiency is varying. So this will help you how your power is varying. So this will help you to in understanding better. So what outer diameter should I fix? So suppose if you see the last one selected, so this will be an outer diameter of say 60. For 60, it is giving the maximum torque and maximum efficiency. So previously we had selected 54.65. So in this way, you can optimize all these parameters. Whatever is in the yellow color, you can parameterize it and you can see for yourself how you are getting the outputs. And so you'll get a confidence that your design is working and it's okay. So now this is about Express. It is very easy to understand. Now, if you go and see here, this is the JMAC designer tool. So I have already opened it because the time constraint, we have only 1 hour and I think only 5 minutes are left now. So this is the GUI of the designer window. So this is the model that I have exported from the Express. Now, if you see, if you go to the 2D model, you can create your new study here. So all these type of analysis are possible for this particular motor model. You can do the static analysis, transient analysis, frequency analysis. So if you are using direct express to export, all these conditions will be automatically assigned here. So a study has already been created based on your express project. And if you see here, you can see all the materials that we have selected in express has been assigned here. So this is the copper for the coil. The stator core has a material of F58,000. Rotor magnet is the NdFeB neodymium with 1 Tesla flux density. And the rotor core is 58,000. And similarly, in the conditions, all the conditions has been automatically set because it is being transferred from the Express, the FEM coil condition. So whatever winding details you had provided in the Express, so if you see, you had provided some winding details here. So whatever winding details here you have provided, it has automatically come and the conditions has been set here. And also the motion condition. So what part of the motor is rotating? So the motion region has automatically sent. The torque region has been sent. The symmetry condition has been set. So suppose if these conditions, suppose you are doing a designer model from scratch. Suppose you are importing your CAD model directly to your designer. All these conditions you have to set your own. You have to, suppose you go to the toolbox section on the right hand side, you can see the materials. So from these materials, you have to select and drag it down, drop it on the stator core, rotor core, copper coil, etc. And in the condition section, you have these many conditions with respect to the 2D analysis, transient analysis. So whatever conditions you see here, it has been assigned because it is being transferred directly from Express. In other conditions, you have to assign all the conditions individually, the FEM coil, the motion condition, torque condition, etc. And now, like another important point I was mentioning you, like if you see the circuit option here, if you right click and press view, you can see this is the inbuilt drive that is there in the Express. So you can't do any changes or modification in this drive details here in the Express. But now you can do the changes. So there are n number of options available, n number of tools available within the circuit editor window, and some constant parameter options, some derivations and integrators, sign values, cost values. So whatever algorithm you have to develop, you can develop it here and input into your drive so that you will get a drive of your requirement here in the designer. And once all these things are set, there is an option for meshing. So now if you see, like I told you, if you go to the mesh properties, we are using method 2 for the current analysis. There are different options. You have standard meshing, slide meshing, meshing at a particular step. So all these options are available. So you have to do your meshing analysis after you specify all the condition details. So this mesh takes care of how much small your mesh should be, how much accurate your analysis should be, what should be the model length for your analysis. So how much ever analysis model length you are giving higher, the better will be the accuracy for your particular motor model. So once you are done with that, you can generate your motor model and you can see the mesh. So it will generate the mesh on its own. And if you see here, this is the mesh for the particular. The top, there is an option to see the mesh. So this is the mesh that has been made for this particular motor model. And now if you want to run this model, you just go to the study, you go to the properties, and you have to fix these properties, and then you can run the active case. So while running, you can see all these values, the torque, for example, torque, flux, current, rotation, all these values you can see together while the motor is being run. So this is there is one more thing I forgot to tell you, like JMAC supports automatic meshing operation. So suppose you don't have much idea about your meshing operation as well, then you can use the automatic meshing operation so that your mesh will be automatically assigned based on the conditions and the materials that you have provided. So whatever analysis you have selected and whatever conditions you have selected, based on that, the automatic meshing operation will be taking place. So now if you see, you can see how the torque is varying for this particular motor model. So everything you can see. So if you customize, if you see, I want to see how the current is flowing in the UVW coil. So now it is in the transient state. So it will take some time for the steady state, for it to reach the steady state. And normally we practice for any simulation, we have to reach the steady state. Only then the analysis will be perfect. So I think it's already 3 o'clock. I will take 2 or 3 minutes just to show you the results out of the designer window. And then I will hand it over to Joseph, who will be taking the efficiency map analysis. So the torque is now fluctuating from 1.5 to 1 Newton meter. And the current is almost 2 ampere. So we had set it a low current for this application. So now you see the motor has run, and down if you go, there is a results option. So here, if you go to the result and if you press the contour plot, you can see different types of options available. You can see the magnetic flux density, current density, the joule loss density, iron loss density, all these things you can see. Suppose I want to see the magnetic flux density, I press apply, I press OK. There is also an option in the top. If you can see my cursor, there is an option to animate this motor. If I press play, you can see how this flux is being varying and where the maximum flux is coming and where the minimum flux is coming. So suppose if I press stop and I say I want to see the flux at this point, if I press it down, you can see the magnetic flux density, the absolute value of magnetic. So similarly, likewise, you can see the vector plot, the flux line, and also under the graphs, you can see different steps. Suppose if you show the table, you can see the torque value, the joule loss value. You can export these values to the CSV file or the Excel sheet file. You can register it as a response data, and you can create another conditions like torque conditions. You can see torque ripple conditions. All these conditions you can set from these graphs. And also one of the important features I told you, there is a self-learning system. So if you go to help self-learning system, there is a self-learning system within JMAC designer window. Sorry, I think because I have opened it, this is not coming. So there is a self-learning tutorial. So that self-learning tutorial will cover the entire aspects of JMAC designer. So from the scratch, how to develop the stator, the rotor core, the magnet core, how to put it into the designer, how to set the materials, how to set the conditions for that, how to draw the circuit for that particular motor model, and how to get the results. So all these things are mentioned here in the self-learning system that is provided here. So this is an overall idea about the JMAC tool, an introduction to the JMAC tool. I know it's a very hard thing for you to digest. People who have used these FEA tools would be able to understand it in a better way. For the others, I think this is just a starting for you to understand the machine design aspects using FEA analysis tool. So I think that is it. Hopefully, I have done some justice to the session, and hopefully you have understood your things with respect to this. Now I will hand over the session to Mr. Joseph, who will be dealing the efficiency map analysis for you using JMAC analysis tool. So thank you for your time, and everyone stay home, stay safe. It's the Corona time, and try to make maximum utilization of your time at home. So thank you very much for your time and support. Bye.
Good afternoon, one and all. This session will be based on performance analysis of an electrical motor using efficiency mapping. Myself, Joseph J. Manali, working as a JMAG support engineer here in PWSIM Engineering Solutions Private Limited. So, without wasting our time, we will start the session on performance analysis of electrical motor. So, coming to the contents, we will go through the following contents here. The first one will be overview of efficiency mapping. The second one is generating efficiency loss and inductance map using RT Viewer. In that, we'll be having subdivisions, benefits of using RT Viewer, how RT Viewer works, configuration and settings, generating a torque speed curve using RT Viewer, exporting results and settings, conclusion and the required licenses for using this JAMAC RT Viewer. So, coming to the efficiency mapping, you might have seen this before. The efficiency map for an electrical machine is a counterpart of the electrical machine efficiency on axis of speed and torque. Basically, this efficiency map will describe the maximum efficiency for all the operating regions. Basically, for any torque speed combination, it's a convenient method to represent a motor drive over this particular range. So this webinar demonstrates how to create efficiency map using a tool called JMAG RT Viewer within a few steps. So coming to the test bench for motor efficiency analysis, usually we'll be having a test bench in the real time. So we'll be having a speed torque sensors that are the crucial parts along with the dynamometer. So it allows accurate measurement of motor performance and will provide some data based upon our drive and operating region, and we will calculate our efficiency based upon this input and output power. And testing this electrical motor, each and every motor will be tested in the test bench with a wide range of power outputs and drive patterns. So coming to the challenges in real-time efficiency mapping using real-time test bench, we can see the excitation parameters. The phase and current amplitudes should be precisely controlled over the wide operating range within the drive circuit. So, and the second one is, it is difficult to find optimum efficiency at each point by calculating the input power and output power in that particular driving region. So, introduction to JMAG RT Viewer. So, JMAG RT Viewer is a tool which is used to create a torque speed curves and efficiency map using the data output, which we get from JMAG RT module, and we can also get it from JMAG Express, as Sadeep explained already in the previous session. So here you can see the efficiency map, copper loss map, iron loss map, and we can generate these graphs with Excel sheets also. So coming to the type of motor supported for mapping evaluation graphs in JMAG RT Viewer. So these are the available type of maps which can be generated or which is basically supported in JMAG RT Viewer. So we will be having graphs with 2 axes and graphs with 3 axes. The first one is NT torque curve, that is speed torque curve, DQ current versus speed curve, current amplitude versus speed curve, and in the graphs with 3 axes, we will be having efficiency map, iron loss map, coil loss map, coil loss bar, iron loss map, D-axis current map, Q-axis current map, phase current amplitude map, D-axis current versus inductance map, Q-axis current versus inductance map. So similar to this, we will be having a set of graphs which is supported in the induction machine sections also. So here, some of the parameters are not considered in this analysis are mechanical losses, inverter losses, effects of eddy currents in the magnet, and effects of PWM carrier harmonics. So these effects are not considered in the calculation of motor efficiency. So coming to the benefits of JMAG RT Viewer, this RT Viewer will be working as an independent module and it is easy to use module. So coming to the real-time test bench, we need not have we don't require any physical test setup for the mapping of performance of this particular machines, and we will be having different control logics for plotting these characteristics. And the third advantage will be we will be considering the magnetic saturation and temperature rise in different parts of machine. Say for an example, for the coil or for the magnet and for the stator rotor core, we can have the separate analysis for each part. And this efficiency plot can be analyzed based upon the non-linear conditions. And accurate results are generated through high-speed calculation by inputting the values. So JMAC RT viewer basically works on a numerical calculations. It's not an FA tool, but we are getting the data once we have completed the FA analysis. So we'll be getting the data from JMAC Designer and JMAC Express, and we will be inputting those numerical data from the actual simulation. So this will be having highly accurate results. And here, coming to the fifth advantage, we can have iron loss simulation results that can be included in the analysis. So coming to the block diagram of what we are doing, it's a user-friendly simulation platform basically. So in the first step, we will create a motor model that will be in a .rtt file format using JMAG RT module, and this RT module we will be inputting it into the JMAG RT viewer. So in the JMAG RT viewer, we'll be configuring the settings and parameters, and we'll be having some coefficients for thermal and inductance details. So that can be inputted in the JMAG RT viewer, and by clicking on the torque speed curve or efficiency map, we can generate efficiency loss, LD/NQ maps, or NT. So this is just for an idea of how we are getting efficiency map using JMAG RT viewer. So how we can create a JMAG RT model? So as Sadeep explained already, we'll be having two environments. The first one is JMAG Express, and the second one is JMAG Designer. And the third one, which I am explaining, is the JMAG RT module. So the results which we are getting from JMAG Express or JMAG Designer can be imported into JMAG RT module, and this JMAG RT module will create the RTT file or .rtt file. So the results which we are getting from JMAG Express will be in numerical form. So these data will be directly imported into JMAG RT module. So apart from that, if you already having some actual measurements from your real test bench, you can import that values in the form of CSV files into the JMAG RT module. So that also you can imported into JMAG RT model, and we'll be having an online mode for motor models that also can be imported into JMAG RT model in order to generate JMAG RTT file. So coming to the different control methods which is available in JMAG RT viewer. So the first one is ID equal to 0 control. So you can see, hope you can see the screen in the center. So here you can see the inverter rating, the control types, the coefficients, leakage detectors, and temperature correction factors. We'll be going through each of these modules. So coming to the control type, in the basic control, we'll be having ID equal to 0 control. In that, we'll be controlling the D-axis current to 0, and we'll be consequently we will be looking into the performance values. Coming to the second control, we will be having maximum torque for current control, MTPA control. For a specified current, the current phase is controlled in order to maximize the torque. The third one is maximum torque per flux control, MTPF control. So this control logic will work in order to achieve maximum torque with a minimum linkage flux. And third one is maximum efficiency control. For this specific current, current phase is controlled so that it will maximize the efficiency. And the fifth one is moment of force control, or PF equal to 1 control. For a given current, the current phase is moment of force equal to 1. And the sixth one is flux weakening control, FW control. The phase of a current for a constant current amplitude, so that the voltage is lower than the limit which we have fixed initially for a particular current value. And the last one is maximum power control. So this maximum power control or MP control combines the benefits of all these control logic. So coming to the settings which we have just explained now. So you can see we need to set the inverter rating like maximum voltage or Vmax should be set in the dialog box, and maximum current in which we are operating also should be mentioned in the dialog box. So this maximum voltage or Vmax is a DC voltage supplied to the inverter. So here we are going through the IPM motor design. So we are not going into the three-phase induction machine. So as of now, we will be going through permanent magnet synchronous machines only. So coming to the maximum voltage control, so you can see a dotted voltage source. So this is a DC voltage supplied to the inverter. So in the star connection, it will be like √3 into V phase. So Vmax will be almost equal to √3 into V phase in star connection, and in delta connection, it will be less than or equal to V phase. And maximum current that we need to enter into the settings will be the maximum amplitude of line current flowing from the inverter to the motor. So when the amplitude of motor phase voltage is set to I phase, it is controlled within a range of Imax will be less than or equal to I phase in a star connection, and in delta connection it will be less than or equal to √3 into I phase. So coming to the main advantage of non-linearities we are considering in this analysis, the first one is increase in coil resistance. So as you know, when the temperature is increasing, the coil resistance will also increase as shown in the graph. So these effects will be considered when we are using this RTV1. And the second one is reduction in inductance with saturation. So there will be an effect of demagnetization on the magnet when saturation comes. So these demagnetization effects or nonlinearity effects will be taken into account when we are doing efficiency mapping in RTV1. And the third one is, you can see thermal demagnetization of magnets. So this thermal demagnetization of magnets, in the long run, there may be a chance of demagnetized magnets in the motor, so it will reduce the life cycle of our particular motor. So these effects can be analyzed using RTV1. So the correction factors and resolutions which we are inputting into the RTV1 window. So here you can see the correction factors in inductance, flux, and iron loss coefficients. So we can specify the correction value. So basically, these are the multipliers for the physical quantity. And this calculation accuracy we can increase based upon the number of current divisions which we are inputting, or when resolution is more precise, your graphs will be more accurate. So you can increase the current divisions in order to increase your resolution. And coming to the leakage inductance, you can mention the leakage inductance in U, V, and W phase when we are coming to the second tab. And third tab, this is what I have explained in the nonlinearity analysis. So here you can see the temperature correction factors. So this can be specified on coils and magnets with same values or independently. So if you are clicking on none, no parameters are selected. When you are clicking on coil only, you can select the coil temperature, the base temperature, coefficients of temperature, minimum and maximum range, and divisions. Similarly, if you are selecting only the magnet, you can give the details for only particularly for the magnet. And if you are selecting both the same temperature, the first values which we are inputting will be copied to the second tab, like magnetic temperature. And you can set it in a different way also. So you can click on both different temperature. You can set the values differently for both the coil and the magnet. So as I have already explained, if division is increased, the calculation accuracy increased for the speed torque curve and efficiency map. However, it will take much more time for the calculation in order to calculate this much number of cases. So for an example, you can see in the divisions, you can see the 3 and 3 is given in the number of divisions for the coil and magnet. So for example, n is equal to 3 and m is equal to also 3. So 3 plus 1 into 3 plus 1. So 4 into 4, 16 cases will be generated when we are considering this particular example. So coming to the correction factors for skew, you can see we can apply, even if you are importing a 2D model also, you can have correction factors for skew. So basically, skew is expressed by stacking and averaging numerous cross sections or multi slices. Actually, in JMAC, in hello, in JMAC, JMAC Express, sorry, JMAC RT Viewer will be having an option for multi-slicing our stacks. So these multi-slices will be stacked or over one another, and we will be looking into the skewing effect by taking linear skew or V skew or step skew. So here, for accurate analysis, we will recommend to use 3D model for this particular model of analysis. So coming to the efficiency control topologies which we have discussed, as I already explained, we'll be having different operating regions for a particular type of motor. So coming to this particular example, when we are having this graph, you can see the first region, the maximum torque per current control. Here you can see the inverter voltage which we have given will be sufficient in this part, and current reaches the upper limit. So we'll be getting a constant torque in this particular range. And in the second range, you can see a particular point. So at that particular point, the voltage starts to dip. So this is because basically of the flux weakening control, and it will starts dipping at a particular value. So these are all maximum output constraints. So here in the inner region will be defined by maximum efficiency control, so that it will operate through a maximum efficiency operating regions. So it is specified by maximum efficiency control. And you can see the flux weakening control, the dashed sloping curve. So here you can see the torque is maximized within the voltage supply abilities. So even though the voltage is dipping from a particular point, the torque is maximized within the range of voltage supply abilities. So other than these four methods, we already discussed about the ID equal to 0 current control method. So here you can see the borderline is determined with the specific control method. So you can see the dashed line, and the inner region is defined by maximum efficiency conditions. So voltage is insufficient with ID equal to 0 control, and we'll be having a fixed or specific operating range for this particular control method. So we'll be going for the other control methods. So coming to the type of plots available within this RT viewer, you can see when you are clicking on the display button here, you can see NT efficiency map, NT iron loss map, copper loss plus iron loss, ID map, IQ map, and phase current maps, LD and LQ map. These are all the plots which is available in our RT viewer. So coming to the torque speed curve, other than this efficiency map, we can generate torque speed curve also. So when you are clicking on the torque speed curve button, it will generate a torque speed curve. So here you can see at a particular speed of 2000 RPM, the flux weakening will start and the voltage starts to dip. So this is how we can observe our performance curve. So coming to the export option available in JMAG RT viewer, we'll be having many options to export. So the first one will be we can export it in a PDF file format, as you have seen in this particular window. And the second one is you can export it in the image format, either in JPG, JPEG, PNG, TIFF, or BMP format. And coming to the third format, if you want to send it in the digital format or CSV file format, you can do that, and you can later create a CSV file or 3D file like this. So this is how we can, this will be really crucial when you are designing your. And coming to the overall settings, so we have specified all these settings in our JMAG RT viewer. So coming to the inverter rating, we have already discussed of setting the phase voltage or maximum voltage which can be given into the bus, DC bus. And the second one is the motor input current, and the third one will be the basic control strategies which we can implement. And the fourth one will be the coefficients, leakage inductance, temperature correction, and skew factors. And here you can see all these details. So all these details and settings can be carry forwarded to the next analysis in the form of .xml file format. So this file format can be saved using the file menu, the save settings option. So there you can save the settings in XML format. So coming to the JMAC RT Viewer application. So it's an application to increase the usability of motor models created using JMAC RT. So the models can be used in control simulators like Simulink or Sidings or any other platform in order to reproduce the phenomena of including the non-linear characteristics and torque variations of particular motor. So coming to displaying the output characteristics, we can generate efficiency maps and other torque speed torque curves for a particular motor model. And coming to the comprehensive most we can have this all in this particular RT viewer, and confirming that variations of output characteristics based on the control method and nonlinear conditions. We can generate CSV files and we can compare the results which is available with us using the CSV file format. And coming to the licenses required for JMAC RT viewer, there are 3 different types of licenses for JMAC RT viewer. The first one will be free. So there you can see the header information of your particular motor. So this version of JMAC RT viewer can be used once you have downloaded it from website. The type 2 license you can apply. This is also free version. You can apply for the license and you will be getting this after verifying all your details. So in this particular type 2 license, you can generate LDLQ maps, speed torque curves, efficiency map, and loss maps. So for that, you can apply through the JMAG International website, and you will be getting a user ID and password in order to access all those details. And coming to the type 3, a proprietary license will be required for more accurate analysis and for your custom-based templates, and this is based upon the purchase of your software. So coming to the real-time scenario, I will explain how we can create all these things. So coming to the JMAC RT viewer, here you can see under JMAC designer, you can see the modules JMAC RT viewer. So when I'm clicking on JMAC RT viewer, this dialog box will be opened. So when you're clicking on file, you can open the file which is already available in the RTT file format. So either you can create it from JMAC Express module or you can create from JMAC designer. So I'm just opening the window Sadip already closed in the previous session. So here you can see this is the model which Sadip already developed, I think so. So here you can see icon called RTT. So when you're clicking on the RTT file option, it will ask whether you want to save this in the form of .rtt file. So you can browse your folder. So it will be saved in the form of .rtt. So this file will be directly imported to the JMAG RT viewer window. So here you can see it will be saved. So coming to the Simulink file types. So if you already having a MATLAB and you want to make some simulations based upon this particular motor model, you can copy files required for simulator also. So either it will be in the form of Simulink electrical signal input, Simulink current signal input, or voltage signal input, or you can directly import it for PWSIM software also. And if you want to have your nameplate, you can input all these details for the header information of your particular model. So once I'm clicking OK, an RTT file will be generated. So coming to the RTT files, now you can see so this RTT file will be created in JMAC Express IPM motor for the JMAC Express IPM motor design, and here you can see JMAC RT for PMSM machines is created for MATLAB application, and you can use this for PSIM applications also. So this is how we can create JMAC RT model, as I have already explained in this slide. You can see JMAC Express. From that, you will be creating a JMAC RTT file, and it will be imported into the JMAC RT model. And the second one is from JMAC design, how we can create a RT model. So this is the same model which I have already imported here. So here, from the study, already you may have seen this animation and all. So I am not going to into that. I'm just clicking on export JCF file. So here it will ask whether you want to create or you want to export a JCF file. So this JCF files will be imported into another module called JMAC RT, and we'll be creating a RTT file. So this is the usual procedure for creating these details. So here it will ask whether you want to save a JCF file. So I am saving it now. So I am creating a JCF file as of now. So here you can see the file format for particular JMAC designer in .jcf file format. So this JCF file will be imported directly into a module called JMAC RT. So here you can see under JMAC designer 19.0 version, you can see JMAC RT. So this is another module for making this JMAC RTT file, which can be further used for creating efficiency map, or it can be for creating your drive designs in MATLAB or PSIM. So when I'm clicking on that, it will open. So here you can create a new motor model. So it will ask which type of motor model you are importing into this particular RT. So as of now, I am going with 3-phase permanent magnet synchronous motor. So I'm clicking OK. So it will ask whether you want to create a LQ model or spatial harmonic model. So the first one will be taking care of the D and Q axis inductance are dependent on current and phase advance angle. So here, the first method, we are not considering the slot harmonics. But when you are clicking on spatial harmonic model, we will be considering the inductance and torque dependent upon the current and phase advance angle, and the slot harmonics will also be included in this calculation. So here I am clicking on LDLQ model for the form Fidel analysis. So here it is asking for the JCF file which I have created just now. So I am just creating a JCF file using the mesh data. So here you can see the model which we have created just now. So when I'm clicking OK, it is showing iron loss condition is not set up. So if you want to include your iron loss calculations in JMAC Express analysis, here under the conditions, you can see the iron loss losses here. So you can drag and drop this iron loss condition into your stator and rotor core, and you can apply the loss factor in the analysis. So I am clicking OK now. So it will ask to enter those details which is already available with you if you want to publish your motor information, and if you want to give some data input, you can click on create button. So in the create button, you will be having number of poles here. So here you can see there are 4 number of poles, and U phase, V phase, W phase coils can be selected here in the phase coils. And in the third section, you can input the number of turns. Already we have created the data here, like 35 number of turns are there. So that you can input in this dialog box 35. And resistance also can be imported based upon the phase resistance which is available here in the express window 0.814. So if you want to consider the leakage reactance, you can input it here. And here you can see how we are giving the current control, LDLQ control here. So here in the advanced settings, you can give the point sequence of current value. Say for an example, if you want to enter those data like 1 amps, 1.5 amps, 3 amps, 2 amps. So the same way you can create point sequence for phase angle also. Say for an example, 5 degree, 10 degree, 20 degree, 30 degree, 40, 50, 60, 90, 120. Actually, it should end 360, as in if you are considering a whole angle till 360. So here you can give. Actually, the current of phase is less than 360 degree based upon our calculation. So it is giving a warning. So you can click OK. So once it is done, you can click on OK button here. So again, you can, this is my motor model, the last one. I can create a model based upon the data which I have given. So the calculation will start automatically, and it will take the value which we have inputted in the form of .jcf, and it will be calculating all these parameters based upon the value which we are inputting. So it is showing that the calculation process is going on. So in order to save the timing, I have already opened one more RTT file here. So here you can see in the file menu, you can open, so this is a RT viewer window. So as of now, I have created 2 RTT files. One is for JMag Express and one is for JMag Designer using the JCF file. So here in the file menu, you can see the open window. So here you can see the model which I have created using Express model. So this is the first model which I have created using Express. So I can click on open. So the file will be selected here. So this is how we can input all the data which I have already explained here. The first one will be 3 point maximum voltage will be V max. So here you can increase the value if you want. And these are the control which is available with us, which I have already explained. So here I can reduce my speed like 3000 RPM. So these are the coefficients in which I can apply the leakage coefficients for inductance, flux, and iron loss. And the leakage inductance value, if it is there, you can input all those data. And the temperature correction factors. So this is the correction factor which I already explained. So if you have all these details available with you, you can click on coil. So here you can see the number of divisions. So usually, if you want to increase your calculation accuracy, you can increase the number of divisions and have better accuracy or resolution. So if you don't want this much accuracy, you can make it in the form of 1 or reduced number. So in the magnet, when I am clicking on magnet, this coil temperature side will be disabled, and you can give only values into the magnet temperature patterns. So when I am clicking on both same temperature, it will be showing the same value which is given for the coil temperature. And in the different temperature when I am clicking, you can individually mention all this data. machines having different temperature setting, you can give those data. So this is how we can create the value. So we can see the JMAG RT library manager window, and it is showing like it is the time left is 14 seconds in order to create an RT model from JMAG designer. So this will be having more accuracy compared to JMAG Express, since it is a detailed FEA analysis and the mesh data we are getting from the JMAG design. So once we have inputted or completed this entering value, you can click on the efficiency map button in the down part. So when I'm clicking on the efficiency map button, it will start creating this efficiency map. So apart from that, in the left side, you can see the title information. So using the JMAG free version, the type 1 license, you can see only the header or the details which is available like in the form of text like this, parameter values and all these things. And in the second type 2 license, we'll be having all the details like LD, DQ and other maps. So this is a curve which is generated for a particular express model. So here you can see, as I have already explained, we have selected only the maximum power control type we have selected. So according to that, we got a curve for efficiency maps here. So here we have provided a gen data. Based upon the model, we have given some data. So it may not be fully accurate. So based upon your inputs, you can give those data, and you will be getting this type of efficiency map. So apart from this efficiency map, you can go for NT iron loss maps, NT copper loss map, copper loss plus iron loss maps, ID map, IEI map, LQ map, LD map. So usually how you can export this data. So here you can see this is a three axis graph. So here you can see export option. So if I'm saving this file in the PDF format, I can save it in this following format. If I'm saving it in the PDF format, I'm generating this. So here you can see the file is generated in the form of PDF file. So all these details will be given along with this efficiency map. This is PDF export option. So apart from that, if you want to export a CSV file, you can export it in the form of spreadsheet file. So I am saving this. So here you can get it in the form of curve, in the form of digits or numerical data. So you can plot your own graph based upon this inputs. And in the form of, you can save it in the form of PNG also. If you want to save it in the form of PNG, you can click on the images option. Then it will be saved. So this is how we can create all this data based upon your motor models. And coming to the second thing, if you want to generate a curve based upon the NT data, only NT data, you can click on the NT curve here. So only the speed torque curve will be generated, and you can go through the performance analysis. So here you can see the torque is getting at a point of 3.2 Newton meter, So it starts dipping at a particular point of 2500 RPM. It starts dipping. So it's because of the flux weakening control. So the voltage starts dipping at this particular point and it will reduce. So this is how we can analyze. So if you want to see the full graph, you can make it into 10,000. Say for an example, 10,000, and you can generate a empty curve. So it's taking some time in order to create this RT empty curve. So apart from that, if you want to have a detailed control, say for an example, if you want to compare the results of different types of control, you can click on detailed control and you can generate graphs. So this is the curve which I have already explained, the speed torque curve. Here you can see it start dipping at a particular point of 2614 RPM, and the torque starts dipping from this particular point. So this is how we can generate speed torque curve. And if you already have inputted your values in the form of temperature correction factors, you can change these values. This coil temperature and magnet temperature can be increased or decreased. And based upon that, you can evaluate your performance of your particular motor. So this is how we can generate all these curves. And apart from that, if you want to change the temperature unit, you can make it in the degree Celsius or degree Fahrenheit form. And as of now, I have created a graph only for particular axis. Say for an example, first quadrant. So if you want to make it for generating mode also, you can click on efficiency map range. You can click on efficiency and motor generate mode, and you will be getting the data for the second axis also. So this is how we can generate all this data. So these type of control techniques can be applied on each particular motor model. Say for an example, for three-phase permanent magnetic synchronous motor, and we can generate this type of graphs. So already we have discussed about exporting this option and displaying these results. So now the last one is, so as I have already explained, you can see the torque versus speed curve and efficiency map in both the axes. Since I have already selected the efficiency map range for motor plus generator model. So this curve will be generated, or the plot will be generated for the first and second quadrant of operation. So this is how we can generate all this model. And coming to the settings option, which I have already explained. So here in the last slide, already explained of saving the settings for the next subsequent analysis of second. So if you want to save this analysis, you can click on File menu, Save Settings. So these settings, particular settings which we have inputted here, will be saved in the form of .xml file. So this is how we can save our model. So coming to the licenses, which I have already explained, the type 1 will be having only header information. The type 2 license, which means you need to apply for a license of type 2. It will be freeware, but you need to apply and you need to get the input the details of your institution and your type of work in JMAC International website. So this is JMAC International website, jmac-international.com. So if you want to apply for a freeware of this JMAC Express, you can click on JMAC Express Online Free Software. So here, when you're clicking on JMAC Express Online Free Software, you need to fill some basic details. You need to apply in the form of institution details. here you can see you can create an account. So the main advantage of Generic Express Online is it can be used in the mobile environment also. So within your fingertip, you can calculate all these basic data. But only the problem is it's having some custom templates based upon that. You can work on that. Other than that, if you want to have custom based designs or your templates, you can give it for purchase option. So here you can apply for by clicking on create an account. So you will be getting all the details and application data which is available in JMAG website. So here you can see the application note and other details. So here you can see JMAG RT Viewer free software. So you can access this free software of RT Viewer by clicking on this JMAG RT Viewer option. So it will be a free version. You can access it and you can use it. So it will be really good when you are taking a lectures or class in a particular module. So you can visualize all these things based upon this sophisticated tool called JMAG FEA. So here you need to enter all these details: start of application, maintenance and application completion. You need to fill all these details, and you need to provide the email ID based upon your. You should not provide your personal ID. You need not. You need to give your institutional login ID. So you can give all this data, and you can click on agree. So usually within 7 to 14 days, you will be getting an access. Mentioning your user ID and password, so you can access these details. And one more advantage is when you see this JMAG international website, you might have known about Professor T.J. Miller. So he's having some wonderful sessions in the motor models. So you can participate in that webinars also. So here you can see already the webinar started from 1st May onwards. So you can participate in this webinars also based upon Professor T.J. Miller sessions. And coming to our company website, this is our company website. So here these are the training programs and events, upcoming events based upon JMAG and PWSIM. So here you can register for these sessions also, like IPM topology optimization and other sophisticated tools are there. So you can go through these free webinar sessions already started, and you can participate in that. So this is how you can apply for these sessions. And if you have any queries, you can ask. Hello. So if there is any query, you can raise your hands and so I hope Sadip already explained all these details. So if you have any queries, you can mail to us. So this is my email ID. Or you can mail to Sadip also. So these are all mail IDs. You can send your queries into this personal mail IDs. We will be looking into your queries and will be answering back. So thank you all for attending this session. I would like to thank Satish Kumar sir and NHC College for arranging this webinar and providing a chance to represent our company. Thank you all.